There is a moment, a feeling that strikes you when you stand in the shadow of a structure like the Great Pyramid or gaze up at the silent, imposing Moai of Easter Island. It's more than just awe at their sheer scale. It's a subtle, almost subconscious recognition of an underlying harmony, a silent rhythm etched into the stone itself. These aren't just random piles of rock. They feel arranged, composed, as if following a sheet of music we can no longer read. For centuries, we've marveled at how they were built, but we may have been missing the real question hidden in plain sight. Not just how, but why were they built with such impossible precision? What if these monuments are not merely tombs or temples, but pages from a forgotten global language, a message carefully encoded in the universal dialect of mathematics and stars? This is the core of a mystery that stretches across every continent and echoes through thousands of years. From the sprawling plains of Salisbury to the high Andes of Peru, ancient builders employed a shared set of geometric rules, specific ratios and proportions, with an accuracy that defies simple coincidence. The same mathematical constants that describe the elegant spiral of a galaxy or the growth pattern of a shell are meticulously woven into the dimensions of their greatest works. This video is an investigation into that provocative idea that a lost civilization, perhaps one remembered in global myths as giants, possessed a sophisticated knowledge they deliberately embedded into the very fabric of their architecture. They weren't just stacking stones, they were writing, and the subject of their text was nothing less than the fundamental order of the cosmos itself. So we are about to become detectives in a case that spans millennia. We will examine the evidence from the perfect angles of the pyramids that seem to capture the number pi, to the celestial alignments of Stonehenge that track the sun and stars with uncanny precision. We will weigh the theories of a universal unit of measurement and listen to the whispers of sacred geometry that turn stone into symbol. This journey will challenge everything you thought you knew about our ancient past, pushing beyond conventional archaeology into a realm where history, mathematics, and myth collide. It's a story of a potential cataclysm that erased this knowledge and of the enduring clues left behind for us to find. By the end, you will not look at these ancient wonders as silent ruins, but as chapters in an epic, unread book, waiting for their story to be told. But what exactly are we talking about when we use the word giants? It's a term that conjures images of towering, mythical figures, but the reality embedded in ancient stories is far more nuanced and widespread. To grasp the full picture, we need to listen to these tales not as literal history, but as a chorus of human memory, echoing from every corner of the globe. In the Hebrew Bible, we find the Nephilim described as the offspring of the sons of God and the daughters of men, powerful beings of renown who walked the earth before the Great Flood. Across the Mediterranean, Greek mythology speaks of the Titans, a primordial race of immense power who preceded the Olympian gods and represented the colossal, untamed forces of nature. Journey to the frozen north, and Norse legends tell of the Jotnar, giants who are often in conflict with the gods themselves, beings so integral to their cosmology that the world was literally created from the body of one, Ymir. This pattern of enormous primordial beings is not confined to the Western world. Across the Atlantic, the traditions of various Native American tribes, such as the Paiute, speak of the Seetika, a race of red-haired giants who were said to be both fearsome and skilled. In South America, the Mapuche people of Chile and Argentina have legends of the Cheruf, powerful spirits of volcanoes and mountains, often depicted as giants. And if we look to the annals of more recent history, we find a curious thread in 19th and early 20th century newspapers, which occasionally reported the discovery of unusually large skeletal remains during excavations or farming, claims that, while heavily debated and often debunked, fueled the public's fascination with the idea of a lost race of large-statured people. So we are faced with a critical question. Are these stories meant to be taken at face value as accounts of physically gigantic people, or is the concept of a giant something more symbolic? One compelling interpretation is that giant is a metaphor for a people or a civilization of immense knowledge and capability. Imagine a group of master builders arriving in a region where the local inhabitants possessed only simple stone tools. To them, these newcomers, with their ability to move mountains of stone and shape the landscape itself, would indeed seem like giants, regardless of their physical height. Their technological prowess would be so far advanced that it might as well be considered magical or godlike. In this light, the term giant could refer to a lost advanced civilization, the hypothetical Atlanteans or another culture whose engineering and astronomical understanding was so profound that their legacy was remembered in myth as the work of superhuman beings. This symbolic interpretation helps bridge the gap between folklore and the physical evidence we see in the megalithic sites. The stories of giants provide a foundational narrative, a cultural memory that something extraordinary happened in the deep past. They set the stage for the geometric mysteries we are about to explore, suggesting that the source of this sophisticated knowledge was not a gradual, linear development, but something that arrived, made its mark with breathtaking speed and precision, and then vanished, leaving behind only these colossal stone puzzles and the whispered legend of the giants who built them. So if these giants, whether literal or symbolic, were the architects of these incredible sites, what kind of message did they leave behind? The answer might lie not in written words, but in a silent vocabulary of shape and number. Think about the most universal languages we know: mathematics, music. They don't rely on a specific alphabet. Their truths are self-evident, understandable to anyone who learns their rules. A musical note has the same frequency whether you're in China or Peru. In the same way, a right-angled triangle follows the same Pythagorean theorem regardless of who draws it. This is the essence of the idea. That geometry itself could be a language, but what would it say? It wouldn't convey a simple narrative like the king defeated his enemies. Instead, it would communicate fundamental principles, the very operating system of reality. It would be a language of essence, not event. To understand this, we need to become familiar with its core vocabulary, a set of numbers and ratios that appear with stunning frequency both in human creation and in the natural world. Perhaps the most famous of these is the golden ratio, often denoted by the Greek letter phi, which is approximately 1.618. This number possesses a unique mathematical property. If you divide a line into two parts so that the longer part divided by the smaller part is equal to the whole length divided by the longer part, you've just created a golden ratio. This might sound abstract, but its visual expression, the golden rectangle, is considered one of the most aesthetically pleasing shapes to the human eye. More importantly, it's everywhere in nature. You can see it in the perfect spiral of a nautilus shell, where each chamber grows in proportion to the last by this ratio. It's visible in the arrangement of leaves around a stem to maximize sunlight, and in the intricate seed pattern of a sunflower, which follows a spiral based on phi to pack in the maximum number of seeds. This isn't a coincidence, it's a result of efficient growth patterns. The ratio is a fundamental engine of life itself. Then there is pi, the mathematical constant represented by the Greek letter pi, approximately 3.14159. This is the ratio of a circle's circumference to its diameter, and it's an irrational number, meaning its decimal places go on forever without repeating. This makes it a profound and mysterious constant. Every single circle, from a tiny coin to the orbit of a planet, is governed by this same, never-ending number. It is a universal rule of circularity, so when we find pi encoded into the dimensions of a square-based pyramid, as many researchers argue is the case with the Great Pyramid, it's a breathtaking conceptual leap. It's as if the builders were deliberately merging the linear world of squares with the infinite world of circles, creating a monument that embodies a fundamental truth of the cosmos. These proportions, phi and pi, are what we call irrational numbers. They can't be expressed as a simple fraction, and they represent infinite, perfect concepts. For an ancient philosopher or a master builder, this would have been deeply significant. These weren't just handy measurements for construction. They were glimpses into the divine, perfect order of the universe, an order that imperfect, mortal humans could approximate but never fully capture. This is why these ratios were considered sacred. The philosopher Plato wrote about ideal forms, perfect shapes and concepts that exist in a realm beyond our own flawed reality. By building structures based on phi or pi, ancient architects were perhaps trying to incarnate a piece of that perfection onto the earth, to make the divine tangible. They were creating a bridge between the mortal and the cosmic. This transforms the idea of a language from a metaphor into a plausible theory. If you wanted to leave a message that could be understood 10,000 years in the future, by a civilization that might not share your spoken language, your symbols, or your gods, what would you use? You would use the one thing that remains constant, the laws of mathematics and physics. You would write your message in the proportions of the planets, in the geometry of life, and in the constants that define space itself. The placement of a massive stone circle to mark the solstice sunrise isn't just a calendar. It's a sentence that says, we understand the cycle of the year. The precise incorporation of pi into a pyramid's form is a statement that says, we have grasped the nature of circles and spheres. This potential language is why the geometry of these ancient sites is so compelling. It's not about random beauty. It's about intentional, coded meaning, a silent dialogue across millennia waiting for an age advanced enough to listen. But to truly appreciate the potential scale of this mystery, we need to step back and look at the global canvas on which it's painted. The evidence isn't confined to one desert or one isolated island. It's scattered across the planet in a collection of sites so bewildering that they force us to reconsider the entire timeline of human ingenuity. Let's take a brief, sweeping tour, not to delve into each site's rich history, but to witness a recurring pattern that becomes impossible to ignore. Our first stop is, of course, the Giza Plateau in Egypt. The Great Pyramid stands as the ultimate icon of ancient precision. We're not just talking about big stones, we're talking about over 2 million blocks of limestone and granite, some weighing more than 50 tons, assembled with joints so tight that a credit card cannot be slipped between them. Its base is almost a perfect square, with sides aligned to the cardinal directions with an error of less than a fraction of a degree. This isn't rough construction. It's engineering on a scale that would be challenging even with 21st century technology. Now let's shift our gaze thousands of miles to the west, to the windswept Salisbury Plain in England. Here, Stonehenge presents a different kind of puzzle. Its massive sarsen stones, standing upright and capped with lintels, form a circle that is precisely oriented to the movements of the sun and moon. During the summer solstice, the sun rises directly over the heel stone, casting its light into the heart of the monument. The builders of Stonehenge moved these colossal blue stones over hundreds of miles, shaping them with an understanding of astronomy that seems far advanced for a society often labeled as primitive. The purpose may have been ceremonial, but the execution was fundamentally scientific. From the green fields of England, we travel to one of the most remote places on Earth, Easter Island or Rapa Nui. Here, the silence is broken by the presence of the Moai, nearly 900 giant stone statues gazing inland. Carved from compressed volcanic ash, these figures average 13 feet in height and weigh an average of 14 tons. The largest, named Paro, stands 33 feet tall and weighs a staggering 82 tons. The mystery is not just their creation, but their transportation across miles of rugged terrain to their final ceremonial platforms called Ahu. How did a small, isolated population with limited resources achieve this? The standard explanation of log rolling has been heavily debated, leaving room for the same question we ask at Giza: how was this actually done? Finally, we journey high into the Andes Mountains of Peru, to the fortress of Saxehuaman overlooking the city of Cusco. The masonry here is perhaps the most visually stunning evidence of a lost technique. Enormous stones, some weighing over 120 tons, are cut into complex polygonal shapes and fitted together like an immense, three-dimensional jigsaw puzzle. The curves and angles are so precise that the stones lock together without any mortar, surviving centuries of earthquakes that would topple modern buildings. The seams are so tight that they appear to be fused from a single piece of rock. This is not simple stacking, it is a masterclass in stonework, a technology that seems to have appeared fully formed and then vanished. So what are we to make of this global gallery of giants, separated by vast oceans and seemingly by thousands of years of cultural development? These sites share a family resemblance that is startling. It's the commonality of scale, precision, and a seeming defiance of the technological context we assign to their builders. Whether it's the squared perfection of Giza, the celestial circles of Stonehenge, the imposing rows of the Moai, or the organic, interlocking walls of Saxehuaman, the message in the stone is consistent. Someone, long ago, possessed a knowledge of engineering, mathematics, and logistics that we are still struggling to comprehend. This pattern, repeated across continents, is our first major clue. It suggests that we are not looking at isolated incidents of genius, but at fragments of a much larger, perhaps connected, phenomenon. This shared architectural language hints at a source of knowledge that was far more widespread than our current history books allow. Now, let's take a closer look at a single structure that stands as the ultimate test case for this theory, the Great Pyramid of Giza. It is the grandest and most studied of all the ancient wonders, and its geometry is so precise that it continues to baffle engineers and mathematicians to this day. The first thing to appreciate is its sheer physical perfection. The base of the Great Pyramid is not just roughly square, it is an almost flawless square. The difference in length between its four sides is astonishingly small, less than 0.2%. This means that for a structure whose sides are over 750 feet long, the error is just a matter of inches. Furthermore, the sides are aligned to the four cardinal directions north, south, east, and west, with a deviation of just a fraction of a single degree. Achieving this kind of accuracy on such a massive scale, without modern tools like GPS or laser levels, is an accomplishment that borders on the impossible. But the original pyramid was even more spectacular than the stepped structure we see today. It was once covered in a gleaming skin of highly polished white Tura limestone. These casing stones were cut with such exacting angles that they fit together seamlessly, creating a smooth, sloping surface that would have reflected the sun's rays with blinding intensity, making the pyramid visible for miles. It was literally a man-made mountain of light, Tragically, most of these stones were stripped away over the centuries to build mosques and palaces in Cairo, but a few remain at the very top, offering a glimpse of the pyramid's original, otherworldly appearance. This polished exterior wasn't just for show. It speaks to a level of finish and precision that goes far beyond mere function. It suggests that the builders were as concerned with perfect form as they were with monumental scale. This obsession with precision is where the mathematical coding becomes truly compelling. One of the most famous and debated relationships involves the number pi. If you take the pyramid's original perimeter and divide it by twice its original height, the result you get is approximately 3.1416, which is remarkably close to the value of pi. Now, skeptics argue that this could be a coincidence, perhaps a result of the chosen measurement system. But proponents of the encoded knowledge theory see it as a deliberate and ingenious design feature. They suggest the builders were creating a scale model of a hemisphere, using the pyramid's height to represent the radius of a circle and its perimeter to represent that circle's circumference. In this model, the pyramid becomes a symbolic bridge between the linear world and the spherical, a representation of the Earth itself. This leads to an even more profound speculation that the pyramid's dimensions encode geographical knowledge. Some researchers have pointed out that if you multiply the pyramid's height by 43,200, a significant number in ancient cosmology, you get a figure very close to the polar radius of the Earth. Similarly, the perimeter might relate to the equatorial circumference. Whether these correlations are precise enough is a matter of intense debate, but the very possibility is staggering. It implies that the builders possessed an advanced understanding of the size and shape of our planet, thousands of years before the ancient Greeks are credited with calculating the Earth's circumference. Beyond pi and geography, the shadow of the golden ratio, phi, also falls upon the Great Pyramid. While the evidence is more complex, some analyses suggest that the ratio of the length of a face to half the base length approximates phi. Others find phi in the proportions of the internal chambers, particularly the king's chamber. This constant, which we find governing growth patterns in nature, would have been the ultimate symbol of harmonic perfection for the builders. By embedding it into the structure, they could have been attempting to create a building that was not just a tomb, but a living embodiment of cosmic order, a machine for harmonizing with the fundamental principles of the universe. Perhaps the most comprehensive theory is that the pyramid was designed as a repository of universal knowledge, a stone book preserving mathematical, astronomical, and geodetic constants for future generations. It may have functioned as a calendar, with its shadows marking the solstices and equinoxes, or its passages aligned with specific stars. The sheer density of these potential encodings makes the argument for coincidence increasingly difficult to sustain. When you combine the perfect alignment, the pi relationship, the possible phi proportions, and the geographical correlations, you are left with a mountain of evidence pointing towards a single, inescapable conclusion. The design of the Great Pyramid was the product of a supremely advanced and deliberate intelligence. It stands not as a monument to a pharaoh's ego, but as a silent, enduring testament to a lost science, a concrete poem written in the language of geometry. While the Great Pyramid provides a powerful and concentrated example, the true force of this geometric theory comes from its widespread application. The same mathematical fingerprints found in Egypt appear thousands of miles away, embedded in structures built by cultures that, according to conventional history, had no contact with one another. This pattern transforms an isolated mystery into a global phenomenon, suggesting that pi and phi were not just accidental discoveries but fundamental components of a shared architectural language. Let's journey to the Salisbury Plain in England, to the iconic stone circle of Stonehenge. For centuries, it has been studied primarily for its astronomical alignments, the way its stones frame the solstice sunrises and sunsets. But what if the stones themselves are arranged according to a hidden geometric code? Researchers like the engineer Alexander Thom proposed that the layout of Stonehenge, particularly the relationship between the outer Sarsen circle and the inner bluestone horseshoe, conforms to a series of sophisticated Pythagorean triangles and ellipses. More intriguingly, the proportions between the diameters of these various rings have been analyzed to reveal ratios that closely approximate pi and phi. For instance, the circumference of the Sarsen circle, when compared to the dimensions of the surrounding Aubrey holes, a ring of pits just inside the bank, may reflect a simple multiple of pi. This isn't about finding pi in a single measurement, as with the pyramid, but about seeing it expressed in the relational geometry of the entire site. It suggests the builders were thinking in terms of circles and their universal properties, creating a sacred space that was not only an observatory, but also a physical manifestation of celestial harmony. Crossing the English Channel and sailing into the heart of the classical world, we find another masterpiece whispering the secrets of the golden ratio, the Parthenon crowning the Acropolis in Athens. Although constructed millennia after the megaliths of Stonehenge and Giza, it stands as a testament to the enduring power of these geometric principles. To the naked eye, the Parthenon is the epitome of balanced, elegant beauty. But this beauty is not accidental, it is mathematically engineered. Art historians and architects have long argued that the facade of the Parthenon was designed to fit precisely within a golden rectangle. If you draw a rectangle around the front of the temple, the ratio of its width to its height is very close to phi, approximately 1.618. This proportional system extends throughout the entire structure. The spacing of the columns, the height of the roof, even the subtle curves engineered to correct optical illusions known as intosses, all appear to be governed by this same harmonious ratio. The Greek philosophers, particularly Pythagoras and Plato, held mathematics in sacred regard, believing that numbers were the language of the cosmos. The Parthenon, then, can be seen as the ultimate expression of this philosophy in stone. It was their attempt to build according to the same divine rules that they believed governed the universe, creating a temple that was not just a house for a goddess, but a perfect harmonic entity in itself. But the reach of this phenomenon extends far beyond the familiar monuments of Europe and the Mediterranean. Consider the ancient Mesoamerican city of Teotihuacan, located just outside modern-day Mexico City. The Street of the Dead, flanked by the massive Pyramid of the Sun and the Pyramid of the Moon, reveals a city plan of astonishing geometric rigor. While the analysis is complex and sometimes contested, studies have suggested that the key distances between the major structures exhibit ratios related to both pi and the golden ratio. The base perimeter of the Pyramid of the Sun, for example, is only slightly smaller than that of the Great Pyramid of Giza, and its proportions have been linked to pi. Similarly, the layout of the complex appears to incorporate triangles and rectangles whose dimensions align with phi-based relationships. This is profoundly significant because it places the same mathematical template onto a culture that developed in complete isolation from the old world. The builders of Teotihuacan had their own unique gods, their own language, and their own architectural style, yet they may have been guided by the same underlying mathematical principles as the Egyptians and the Greeks. This isolation makes the argument for independent invention much stronger, but it also deepens the mystery. Why would these specific, irrational constants be the recurring choice for sacred architecture across the globe? This pattern of recurrence is what elevates the theory from curious coincidence to a compelling hypothesis of a shared doctrine. When a specific, non-intuitive number like pi or phi appears once, it might be luck. When it appears in two widely separated sites, it gives us pause. But when we find echoes of it in the proportions of Stonehenge, the Parthenon, the pyramids of Giza, and possibly Teotihuacan, and even in the dimensions of Buddhist stupas and Hindu temples, the probability of random chance dwindles dramatically. These constants are not simple ratios like 1 to 2 or 2 to 3, which might arise from practical trial-and-error construction. They are complex, irrational numbers that require a deliberate and sophisticated understanding of geometry to incorporate accurately. The consistent use of these particular ratios suggests that ancient master builders were not just skilled engineers. They were philosophers and scientists who recognized that these proportions held a special power, an intrinsic beauty, and cosmic significance. They were applying a universal aesthetic and scientific standard, a doctrine that said true, enduring architecture must resonate with the fundamental mathematics of nature itself. This points toward the existence of a very old, and now lost, school of knowledge, a secret science of sacred geometry that was practiced by a global network of initiates, or independently discovered by different cultures because it simply represents a universal truth. While Pi and Phi capture much of the attention for their elegant presence in nature and architecture, focusing solely on them might be like recognizing only 2 words in an entire alphabet. The potential geometric language of the ancients appears to have a much richer vocabulary, incorporating other profound mathematical concepts that demonstrate a sophisticated grasp of form and space. One of the most fundamental is a principle every student learns, the Pythagorean theorem. The idea that in a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other 2 sides is often credited to the Greek philosopher Pythagoras in the 6th century before the Common Era. However, archaeological evidence reveals that this knowledge was possessed far earlier. Babylonian clay tablets, such as Plimpton 322, dating back to around 1800 before the Common Era, contain lists of Pythagorean triples, sets of 3 whole numbers that perfectly satisfy the theorem, like 3, 4, 5, or 5, 12, 13. This proves that the relationship was understood and used for practical calculation over 1,000 years before Pythagoras was born. But did this abstract knowledge find its way into monumental architecture? There is compelling evidence to suggest it did. Look at the triadic structures found in certain megalithic sites. Consider the arrangement of 3 massive stones at Stonehenge forming a massive trilithon, 2 vertical pillars capped by a horizontal lintel. This creates a perfect, monumental right-angled doorway. While building a right angle can be achieved with simple ropes using a 3-4-5 triangle, the consistent application and sheer scale suggest a formal understanding of the geometric principle behind it. Elsewhere, in the temple complexes of Malta like Mnajdra, the layout of chambers often forms precise rectangular units, implying the builders could reliably generate perfect right angles, a cornerstone of advanced planning and stable construction. This wasn't just about making a corner, it was about imposing a grid of rationality onto the landscape, using a theorem that connects algebra to geometry in a beautifully simple way. The presence of this knowledge in both Babylonian mathematics and European megaliths points to a widespread and possibly very ancient understanding of this fundamental rule of triangles. Perhaps even more esoteric than the Pythagorean theorem is the ancient obsession with a challenge known as squaring the circle. This is the task of constructing, using only a compass and a straightedge, a square that has exactly the same area as a given circle. From a modern mathematical perspective, we know this is impossible because pi is a transcendental number. It cannot be expressed as a simple algebraic solution. Yet this did not stop countless ancient philosophers, mystics, and architects from attempting to solve it, or at least to symbolically represent it. The concept holds deep philosophical weight. The circle has always represented the divine, the infinite, the celestial, and the eternal, having no beginning and no end. The square, by contrast, symbolizes the earthly, the material, the four cardinal directions, and the domain of humans. To square the circle was therefore seen as the ultimate act of harmonizing heaven and earth, of bringing the infinite perfection of the cosmos into the finite, measurable world of mankind. It was an alchemical goal, a spiritual endeavor. We find this motif subtly encoded in ancient structures around the world. The most famous and debated example returns us to the Great Pyramid of Giza. Some researchers have proposed that the pyramid's design is a geometric solution to this ancient problem. The theory suggests that if you take the pyramid's height as the radius of a circle, the circumference of that circle is remarkably close to the perimeter of the pyramid's square base. In this symbolic sense, the pyramid itself becomes a three-dimensional resolution of the puzzle, a square base representing the earth, supporting a structure whose height generates a circle representing the sky. It physically fuses the two shapes into one monument. Similarly, in many medieval cathedrals and Islamic palaces, architects would incorporate floor plans or decorative patterns that combined circles and squares in intricate ways, striving for that symbolic balance between the spiritual and the temporal. Even if a perfect mathematical solution is impossible, the relentless pursuit of it reveals a deep desire to express a universal truth, that the material world is not separate from the divine, but a reflection of its underlying order. The very attempt to square the circle speaks to a world where geometry was the bridge between humanity and the cosmos. Beyond these specific theorems and problems, there are other mathematical relationships that emerge from a close study of these sites. The simple yet powerful concept of whole number ratios, for instance, is fundamental to music and harmony. The intervals we find most pleasing in a musical scale, an octave, a fifth, a fourth, are based on simple ratios like 2:1, 3:2, and 4:3. This same principle of harmonic ratios appears to have been applied to sacred architecture. The dimensions of chambers within pyramids or the proportions of temple facades often reflect these same ratios. It's as if the builders were trying to make the very stones resonate with a silent, visual harmony that mirrored the harmony of sound. They may have believed that a building constructed with these perfect proportions would not only be structurally sound, but would also create an environment in harmony with the universe, a space where the spiritual and physical could meet. This expansion of the geometric language from static form to dynamic, harmonic relationship suggests a level of integrated scientific and philosophical thought that we are only beginning to appreciate. It moves beyond mere measurement into the realm of cosmic music, frozen in stone. So far, we've explored the vocabulary of this potential language, the numbers and ratios embedded in the stone. But a language needs more than just words. It needs grammar, a set of rules to structure those words into meaningful statements. This is where the sky comes into play. For the ancient master builders, astronomy provided the syntax, the celestial movements that gave profound context to their geometric vocabulary. By aligning their monumental creations with the sun, the moon, and the stars, they were writing complex sentences about time, creation, and humanity's place in the cosmos. They were orchestrating a grand, perpetual dialogue between the earth and the heavens. One of the most dramatic examples of this celestial conversation occurs not in a desert, but in the rolling green hills of Ireland. The passage tomb of Newgrange is older than both Stonehenge and the Great Pyramid, dating back over 5,000 years. From the outside, it appears as a large, grass-covered mound. but its true magic is revealed for just a few precious minutes each year around the winter solstice. Above the entrance is a small, ingeniously designed opening known as a roof box. As the sun rises on the shortest day of the year, a narrow beam of sunlight penetrates this opening, travels down the long, dark passageway, and for approximately 17 minutes illuminates the inner chamber with a golden light. This is not a vague alignment. It is a precise, targeted event that required an extraordinary understanding of the solar cycle. For a prehistoric farming society, the winter solstice marked the symbolic death and rebirth of the sun, a turning point where the days would begin to grow longer again, promising the return of life. The builders of Newgrange engineered their tomb to capture this moment of renewal, flooding the space reserved for the dead with the light of rebirth. It's a powerful statement, written in sunlight and stone, that connects the cycle of human life directly to the cycle of the cosmos. Traveling across the Atlantic to the Yucatan Peninsula, we find another masterpiece of astronomical engineering, the Pyramid of El Castillo at Chichen Itza. During the spring and autumn equinoxes, when day and night are of equal length, a spectacular phenomenon occurs. The setting sun casts a shadow along the northwestern corner of the pyramid's stepped sides. The interplay of light and shadow creates a series of triangular shapes that slither down the balustrade, connecting the top platform to a giant stone serpent head at the base. The effect is that of a massive, undulating serpent descending from the sky to the earth. This was a direct representation of Kukulkan, the feathered serpent deity associated with rebirth and the sky. For the Maya, who were master astronomers with a complex calendar system, this event was far more than a visual spectacle. It was a confirmation of cosmic order, a moment when the boundary between the divine and the human world grew thin. The pyramid acted as a colossal clock and a calendar, marking a pivotal point in the agricultural year with unerring accuracy. It transformed an abstract astronomical event into a tangible, communal experience, reinforcing the authority of the rulers who were seen as intermediaries with the gods. Perhaps the most famous and debated celestial alignment brings us back to the Giza Plateau, but this time we look beyond the pyramids themselves to the stars they might mirror. The Orion correlation theory proposes that the arrangement of the three main pyramids at Giza is not random, but a deliberate reflection of the three stars that form Orion's belt. Proponents of this theory, like authors Robert Bovell and Adrian Gilbert, point out that the relative sizes and positions of the pyramids match the brightness and configuration of the belt stars. Furthermore, they argue that the southern shaft emanating from the king's chamber in the Great Pyramid was precisely aligned to point directly at Orion's belt around the year 2500 before the Common Era, a time often associated with the pyramid's construction. In ancient Egyptian mythology, Orion was associated with Osiris, the god of death, rebirth, and the afterlife. The Milky Way was seen as the celestial Nile. By creating a mirror image of this sacred constellation on the ground, the pyramid builders could have been engaged in a practice known as astral magic, or as above, so below. They were perhaps attempting to create a gateway for the soul of the deceased pharaoh, ensuring his safe passage to the eternal stars and his transformation into a divine Osiris. This would mean the entire Giza complex was not just a cemetery, but a vast, functional machine designed to facilitate a cosmic journey, permanently linking the fate of the king to the immutable stars. When we step back and view these sites together, Newgrange marking the solstice, Chichen Itza marking the equinox, and Giza mirroring the stars, a profound pattern emerges. The builders were doing much more than telling time. They were creating permanent, earthly anchors for celestial cycles. They were mapping the heavens onto the landscape, turning abstract time into concrete space. This practice of encoding astronomical knowledge into architecture suggests a unified purpose that transcends cultural differences. Whether it was the Celts in Ireland, the Maya in Mexico, or the ancient Egyptians, these cultures shared a fundamental desire to understand and harmonize with the cosmos. The astronomical alignments provided the grammar that structured their geometric vocabulary into a coherent narrative about life, death, and the eternal rhythms of the universe. It shows us that these ancient peoples saw themselves not as separate from nature, but as active participants in a living, breathing cosmos, and they built their world to reflect that sacred connection. Now, if a worldwide architectural language truly existed, it would almost certainly require a common alphabet, a standardized system of measurement that every master builder, regardless of their location, could understand and apply. This idea leads us directly into one of the most fascinating and contentious debates in alternative archaeology: the search for a universal ancient measuring stick. Could builders from the British Isles to the Egyptian desert have been using the same ruler? The most compelling case for this comes from the meticulous work of a 20th-century engineer named Alexander Thom. In the middle of the last century, Thom embarked on a lifelong mission, surveying hundreds of Neolithic stone circles, standing stone alignments, and burial mounds across Britain and France. He didn't just take rough measurements, he used the most precise tools available, like a theodolite, to map these sites with an accuracy that was unprecedented. And after analyzing this mountain of data, he announced a startling conclusion. He proposed that the builders of these sites had used a standardized unit of length, which he called the megalithic yard. According to Thom, this unit was equivalent to approximately 2.72 feet, or about 0.83 meters. What was truly remarkable was his claim that this same unit appeared again and again, from the remote Scottish islands to the coast of Brittany, with a consistency that defied random chance. He even argued that the megalithic yard was subdivided into smaller units, like a megalithic inch, and used to lay out complex geometrical figures, including precise ellipses and egg-shaped circles, demonstrating a level of mathematical sophistication that completely overturned the traditional image of primitive, brutish Stone Age people. Thom's findings were revolutionary, but they were also met with immediate and sustained skepticism from the archaeological establishment. The core of the criticism revolves around the statistical nature of his evidence. Skeptics argued that when you measure hundreds of sites with thousands of individual stones, you are bound to find some numbers that cluster around a common value purely by chance. They suggested that Thom might have been unconsciously selecting data that fit his theory, or that the variations in the measurements were too great to conclusively prove a single, standardized unit. Furthermore, they pointed out the immense practical difficulty of maintaining and transmitting a precise unit of measurement across thousands of years and hundreds of miles without any physical artifact of the measuring rod itself ever being found. If there was a megalithic yard, where are the ancient rulers? Despite these valid criticisms, Thom's work has never been entirely dismissed. Later surveys and statistical reanalyses have sometimes supported his claims, while others have refuted them, leaving the megalithic yard in a kind of academic limbo, a tantalizing possibility that is neither fully proven nor completely disproven. Yet, the idea of a standard unit doesn't stop at the English Channel. When we look at ancient Egypt, we find a system of measurement that is both well documented and incredibly precise: the royal cubit. Unlike the hypothetical megalithic yard, we have physical examples of cubit rods beautifully crafted from stone or wood that have been discovered in tombs. The Egyptian royal cubit was divided into 7 palms, with each palm further divided into 4 digits, totaling 28 digits per cubit. This gives it a length of about 20.6 inches, or just over 1.7 feet. The Egyptians used this unit with breathtaking consistency in the construction of the pyramids and temples. The base length of the Great Pyramid, for instance, is famously recorded as 440 cubits. The existence of a standardized official unit is undeniable in Egypt, but the question for our global language theory is whether this cubit was related to anything else in the world. Intriguingly, some researchers have pointed out that if you take the megalithic yard and divide it by a factor related to the golden ratio, you get a value very close to the Egyptian cubit. Others have tried to link both units to the dimensions of the Earth, suggesting they were derived from a fraction of the planet's polar circumference. While these connections are highly speculative and far from accepted, they highlight the persistent human desire to find a common source for these ancient wonders. This search for a universal measure extends even further. In the Indus Valley, the civilization of Mohenjo-Daro and Harappa used a unit called the Indus inch, deduced from the precise dimensions of their carefully laid-out cities. In ancient Mesopotamia, the Nippur cubit was a standard. The Romans had their pace and the Greeks their foot. So, the real debate is not whether ancient cultures had standardized measurements. They clearly did. The profound question is whether these different units around the world were all independent inventions, born from the practical needs of local builders and rulers, or if they were all derived from a single, primordial standard that dates back to a time before history, a time of the supposed giants. The diffusionist argument suggests that a core unit of measurement, like a precious piece of knowledge, could have been carried along trade routes or by migrating peoples, gradually evolving into the royal cubit, the megalithic yard, and other units, but still retaining a trace of their common ancestry. The opposing view is that any advanced society will naturally develop standardized measures for taxation, construction, and trade, and that the specific numbers they choose might be based on something universal, like the average length of a man's forearm, which is the origin of the cubit, or the pace of a walking man. In this view, the similarities are a result of common human physiology and practical need, not a shared, lost civilization. The implications of this debate are enormous. If Alexander Thom was correct, and a precise megalithic yard was indeed used from Orkney to Portugal, it implies a level of cultural cohesion and scientific communication in Neolithic Europe that we never knew existed. It suggests the presence of a guild of surveyors, an elite class of astronomer priests or master builders who shared a common training and could travel across the land, implementing a grand, unified design. This would be a cornerstone for the theory of a widespread, sophisticated knowledge system. On the other hand, if the skeptics are right, then the megalithic yard is a statistical phantom, and the wonders of the ancient world stand as independent testaments to the universal human genius for geometry and engineering. Whether the units were globally standardized or independently conceived, their very existence speaks to a deep-seated human desire to impose order on the world, to measure the immeasurable, and to build not just for the present, but for eternity, using a language of length and proportion that they believed echoed the very fabric of the cosmos. But beyond the precise alignments and mathematical constants lies a deeper layer of meaning, one that transforms these structures from feats of engineering into profound philosophical statements. The geometry we've been analyzing is not just a tool for construction, it is a language of symbolism, a visual theology carved into the very bones of the earth. To understand these monuments fully, we must learn to read the spiritual meaning behind the shapes, to see the circle, the square, and the triangle not as mere forms, but as sacred icons representing the fundamental principles of existence. The circle is perhaps the most universal and potent of all sacred symbols. With no beginning and no end, it represents perfection, eternity, and the infinite. It is the shape of the sun and the moon, the cycle of the seasons, and the unbroken horizon. Across cultures, the circle symbolizes the divine, the source of all creation, and the ultimate unity of all things. This is why we find circles at the heart of so many sacred sites. Stonehenge is the most obvious example, a massive circle of stones capturing the cyclical dance of the heavens. But the symbolism extends far beyond. The great stone circles of Avebury in England, the circular burial mounds like Newgrange, and even the circular foundations of many ancient temples all speak to this same idea. They create a sacred space, a temenos, that is set apart from the linear, chaotic world of everyday life. When you step inside a stone circle, you are symbolically entering the realm of the eternal, connecting with the cyclical nature of time and the wholeness of the cosmos. The builders weren't just marking a spot, they were creating a portal to the divine. In stark contrast to the infinite circle stands the square, the symbol of the earthly, the material, and the finite. The square is grounded, stable, and rational. Its four sides are easily associated with the four cardinal directions, the four elements earth, air, fire, water, and the four seasons. It represents the world of form, of limitation, and of physical reality. The Great Pyramid is the ultimate expression of the square, its base firmly planted on the earth, its sides aligned with the directions, asserting a mastery over the material plane. But this earthly symbolism is never meant to stand alone. The true power of sacred geometry comes from the dynamic relationship between the square and the circle. The square is the foundation upon which the spiritual ascent is built. It is the stable platform from which humanity can reach for the heavens. In many traditions, the square represents the physical body or the material world that must be perfected and transcended. By building a square base, the ancient architects were acknowledging the reality of the physical world while simultaneously preparing to move beyond it. This act of ascent is perfectly captured by the triangle. A shape of immense dynamic energy, the triangle points upward, symbolizing aspiration, trinity, and the movement from the earthly to the divine. It is the bridge between the square and the circle. In the pyramid, the triangular sides rise from the square base to a point, a symbolic ascent from the material world to the spiritual apex. The triangle is also deeply associated with the concept of Trinity, which appears in countless spiritual systems: the Christian Father, Son, and Holy Spirit, the Hindu Brahma, Vishnu, and Shiva as creator, preserver, and destroyer, or even the simple human trinity of body, mind, and spirit. The triangle represents the resolution of duality, the harmonious balance that emerges from the interaction of three forces. When the ancient builders incorporated triangles into their designs, they were encoding a message about the path of enlightenment, a journey from the multiplicity of the material world, the square, through a process of synthesis, and balance the triangle toward ultimate unity with the divine, the circle. This symbolic language finds its most sophisticated expression in the concept of the Platonic solids. The Greek philosopher Plato, building on earlier knowledge, described 5 perfect three-dimensional forms whose faces are all identical, regular polygons. These are the tetrahedron, 4 triangles, the cube, 6 squares, the octahedron, 8 triangles, the dodecahedron, 12 pentagons, and the icosahedron, 20 triangles. Plato went so far as to associate each solid with a classical element: fire, earth, air, the cosmos, and water, respectively. He believed these shapes were the fundamental building blocks of the universe, the perfect templates from which all matter was constructed. While we don't find giant stone dodecahedrons sitting in the desert, the principles behind the Platonic solids, symmetry, perfection, and the idea that complex reality arises from simple geometric forms, are absolutely central to the philosophy of sacred geometry. The builders may have been expressing this same idea in their architecture, suggesting that their temples were microcosms, miniature models of a universe built according to divine geometric principles. We can see this microcosmic thinking beautifully in the Hindu and Buddhist tradition of the mandala. A mandala is a complex circular diagram that represents the universe. It is a tool for meditation, a cosmic map that guides the practitioner from the outer layers of illusion to the inner center of enlightenment. Mandalas are meticulously constructed using the same geometric symbols we find in megalithic architecture. A square palace at the center, often with 4 gates facing the cardinal directions, enclosed within multiple concentric circles. The entire design is a geometric representation of the journey from the fragmented, square world of material existence to the unified, circular core of pure consciousness. The parallels are striking. Is a mandala so different from the layout of a site like Stonehenge or the Giza Plateau? Both use circles and squares to create a sacred space that models the cosmos. Both are designed to facilitate a spiritual journey. This suggests that the language of sacred geometry is not confined to the West or to a specific time period. It is a universal human impulse to use shape and number to understand our place in the vastness of creation. So when we look at these ancient monuments, we are not just looking at piles of rock. We are looking at libraries of stone, filled with a symbolic language that speaks of the relationship between heaven and earth, the finite and the infinite, humanity and the divine. The circle, the square, and the triangle are the basic alphabet of this language. The precise ratios like phi and pi are its grammar, ensuring harmonic balance. And the astronomical alignments are the syntax that connects this earthly poetry to the movements of the cosmos. The builders were not merely constructing shelters or tombs, they were engaged in the highest form of philosophy and theology. They were encoding their entire cosmological worldview into a form that could withstand the ravages of time, creating a permanent testament to their understanding that the universe is not a random chaos, but a beautifully ordered geometric reality. They built their wisdom into the landscape so that future generations like us might one day decipher its message and remember that we, too, are part of this sacred geometric order. Now we arrive at the question that has haunted archaeologists and engineers for centuries, the practical puzzle that lies at the very heart of the mystery. We can admire the perfect geometry and the celestial alignments, but all of that intellectual sophistication crashes into a very physical, logistical problem. How, with what we perceive as primitive technology, did they actually do it? How do you quarry a single block of granite weighing 70 tons, transport it over miles of varied terrain, and then lift it precisely into place hundreds of feet in the air? The sheer, brute force difficulty of these tasks is so immense that it becomes, in itself, a powerful piece of circumstantial evidence for the advanced builder theory. Let's break down the process, starting at the source, the quarry. In Aswan, Egypt, we can visit the unfinished obelisk, a colossal shaft of granite that cracked and was abandoned in situ. If completed, it would have weighed nearly 1,200 tons. The surrounding bedrock is scarred with trenches where workers, using nothing more than dolomite pounders, harder balls of stone, pounded away at the granite for countless hours, not cutting it, but literally pulverizing the rock grain by grain to free the block. The amount of labor required is almost unimaginable. Similarly, at the megalithic sites, we see evidence of precise quarrying. At the famous Rono-Raraku quarry on Easter Island, the Moai were carved directly from the volcanic tuff of the crater wall, with master sculptors shaping the faces and bodies before they were somehow separated and moved down the steep slope. The question isn't just about effort, it's about technique. How did they achieve such clean lines and precise angles with such basic tools? Mainstream archaeology points to immense patience, generations of accumulated skill, and the use of water and wooden wedges to split stone. Yet, when you look at the polygonal stones at sites like Saxehuaman in Peru, stones that fit together with such complex, irregular joints, the idea of achieving this with simple pounding and splitting feels incomplete. It suggests a knowledge of stonework, perhaps involving the application of specific chemicals or plant extracts to soften the rock, a theory for which there is some anecdotal but controversial evidence. Once the stone was free, the next challenge was transportation, and this is where the enigma truly deepens. Take the case of the colossal statues on Easter Island. The prevailing theory for decades was that the islanders laid the Moai on wooden sleds and pulled them over log rollers, but this theory has faced serious challenges. The island was largely deforested, raising the question of where all the necessary timber came from. Experiments have shown that this method is incredibly difficult and risky, often resulting in broken statues. Alternative theories suggest the islanders might have walked the statues by rocking them from side to side with ropes, a method demonstrated to be surprisingly effective in modern experiments. But this only solves the puzzle for one location. How do we explain the journey of the massive limestone blocks for the Great Pyramid, quarried from the east side of the Nile and transported to the west? The conventional explanation involves floating them on barges during the annual flood, then dragging them on sledges up a giant ramp. This is plausible, but the scale is staggering. We are talking about moving an average of one block every 2 to 3 minutes for the entire construction period, a logistical operation that would be a massive undertaking even with modern machinery. Then comes the most dizzying feat of all, the lifting. How do you raise a 200-ton stone block and place it with millimeter precision at the top of a pyramid, or position a 50-ton lintel stone 20 feet in the air at Stonehenge? The standard answer for the pyramids is the ramp system. Archaeologists propose that massive ramps made of mud brick and debris were built alongside the pyramid, growing with it, and the blocks were dragged up these inclines. However, this theory has its own problems. The volume of material needed for a ramp high enough to reach the top of the Great Pyramid would be almost as large as the pyramid itself. Furthermore, the angles would become impossibly steep, and the archaeological evidence for such ramps is scant. For Stonehenge, the proposed methods involve frames, levers, and counterweights, a system of greased timbers and earthworks to raise the stones incrementally. These are ingenious solutions, but they remain theoretical reconstructions. The precision with which these stones were set, often with complex joinery like the mortise and tenon joints holding the Stonehenge lintels in place, suggests a level of control that is hard to achieve with brute force ramp and lever methods alone. This gap between the proposed conventional methods and the actual, achieved perfection is what fuels more speculative theories. One of the most captivating is the idea of sound levitation. Ancient legends from various cultures, including those of the Egyptians and the builders of the Tibetan monasteries, speak of a lost science where priests or sages could use specific chants or the vibrations from instruments like large drums or trumpets to make stones lose their weight and float into place. From a modern physics perspective, this touches on the concept of acoustic levitation, where standing sound waves can indeed suspend small objects in mid-air. While scaling this up to multi-ton blocks defies our current understanding of physics, the persistence of these stories is intriguing. Could they be a metaphorical memory of a different kind of technology, or perhaps a ritual that accompanied a more practical but still lost technique? Another possibility involves a deeper, more sophisticated understanding of leverage and counterweights than we typically credit to ancient peoples. Imagine a system of water-filled counterweights, where the controlled filling and emptying of large containers could provide a smooth, powerful lifting force. Or consider the use of kites, as some researchers have proposed for the Egyptian pyramids, harnessing the power of the wind. Perhaps the most compelling idea is that the builders possessed a simple but profound secret that has been lost to time: a specific way of tying ropes, a particular pulley system, or a knowledge of physics that was guarded by a secretive guild of masons and never written down. The very fact that we are still debating how it was done, that no single conventional explanation is entirely satisfactory for all the global examples, is telling. The technological enigma forces us to confront a simple but profound possibility: that the primitive technology label we apply to these ancient cultures is a misnomer. It may not be that they had access to alien technology, but that they perfected a human technology of logistics, engineering, and applied physics that was so effective, so elegant, that its methods have vanished from common knowledge. The silent, immovable stones stand as a permanent challenge to our assumptions, a testament to a hands-on wisdom that we have yet to fully rediscover. This brings us to a crossroads in our investigation, a fundamental question that divides historians and archaeologists. Now that we've seen the same geometric principles appearing across the globe, we are forced to ask, was this a case of cultural diffusion, where knowledge spread from a single, advanced source like a stone skipping across a pond? Or was it a series of independent inventions where different human minds, facing similar challenges, arrived at the same brilliant solutions? This isn't just an academic debate. The answer reshapes our entire understanding of human history and the nature of intelligence itself. Let's first explore the case for diffusion, the idea of a single mother culture. Proponents of this view, like the early 20th century scholar Grafton Elliott Smith, argued that the similarities are simply too specific to be coincidental. They point not just to the presence of pyramids, but to shared, intricate details. For example, the practice of building a smaller, subsidiary pyramid alongside a main one is found at Giza in Egypt and also at the ancient Olmec site of La Venta in Mexico. The precise orientation of structures to cardinal directions and celestial events is a complex practice that, diffusionists argue, is unlikely to have been stumbled upon independently dozens of times. They envision a seafaring civilization, perhaps the mythical Atlanteans or a highly advanced prehistoric culture, that traveled the oceans, sharing its knowledge of astronomy, mathematics, and monumental construction with developing societies around the world. This would explain the sudden, seemingly miraculous appearance of advanced building techniques in places like Egypt and Peru, as if a master teacher had arrived, provided the blueprints, and then vanished. The diffusionist theory paints a picture of a connected ancient world, where ideas flowed freely across vast distances long before the accepted dates of transoceanic travel. On the other side of the debate stand the proponents of independent invention. Their argument is rooted in the remarkable capacity of the human mind. They assert that fundamental geometric principles are not secrets to be discovered and hoarded, but are inherent in the very fabric of the world around us. Any intelligent culture that observes the heavens, studies the cycles of the seasons, and engages in large-scale construction will inevitably uncover these truths. The Pythagorean theorem, for instance, is not an abstract idea. It is a practical reality. A builder stretching ropes to create a perfect right angle for a house foundation will quickly learn that a triangle with sides measuring 3, 4, and 5 units creates a perfect corner. This knowledge can be and was rediscovered countless times because it is a simple, observable fact of geometry. Similarly, The golden ratio's prevalence in nature means that artists and architects seeking the most pleasing, organic proportions would naturally gravitate towards it. It's an aesthetic intuition baked into our perception. From this perspective, the pyramids of Egypt and the Americas are not copies but parallel inventions, like the independent development of agriculture in the Fertile Crescent, China, and the Americas. It's a testament to the universal spark of human genius, not evidence of a single lost teacher. Weighing the evidence requires a clear-eyed look at the arguments. The diffusionist theory is compelling in its simplicity, but it faces a significant challenge: a lack of concrete evidence for sustained pre-Columbian contact between, say, ancient Egypt and Mesoamerica. There are no Egyptian artifacts in Mayan ruins, no Olmec pottery in the Nile Valley. The similarities, while striking, are often architectural and conceptual, not cultural. The independent invention theory, meanwhile, elegantly explains the stark differences in language, religion, and social structure between these cultures. The Maya had a complex writing system and a precise calendar. The Egyptians had a completely different pantheon of gods and a unique hieroglyphic script. If there was direct contact, why didn't these other cultural elements transfer as well? The independent invention model suggests that while the underlying mathematics are universal, their cultural expression is uniquely tailored to each society's worldview. An Egyptian pyramid was a resurrection machine for a god-king, while a Mesoamerican pyramid was a sacred mountain and a stage for ritual. The same geometric form served a profoundly different purpose. Perhaps the most satisfying resolution lies not in choosing one theory and discarding the other, but in considering a more nuanced hybrid model. Think of it as inspired independent invention. It's possible that a core set of very ancient fundamental knowledge, a primal understanding of basic geometry and astronomy, did diffuse across the world at a time so remote it is lost to history, carried by early human migrations tens of thousands of years ago. This foundational knowledge then took root in different soils, isolated from one another, separated by rising oceans or changing climates after the last ice age. These scattered human groups then developed that seed knowledge independently. They applied the same basic principles of circle and square, of solar alignment and harmonic ratio, to their own unique environments, materials, and spiritual beliefs. The core geometric language remained constant because it describes universal truths, but the architectural dialects, the styles of the pyramids, the forms of the temples diverged dramatically. This model acknowledges the compelling evidence for both sides. The startling global consistency points to a common root, while the profound cultural differences suggest long periods of isolated development. The puzzle remains, but it becomes a richer, more layered mystery, one that speaks to both the interconnectedness of humanity's deepest past and the incredible, independent, innovative power of the human spirit. So we are faced with a profound paradox. The very existence of these geometrically perfect structures is undeniable proof that this sophisticated knowledge was successfully transmitted from one generation of builders to the next, for centuries, even millennia. Yet today, that knowledge appears to be almost entirely lost, leaving us with only the physical monuments and a sea of questions. How could something so advanced, so crucial to creating the world's greatest wonders, simply vanish? The answer may lie not in the stone itself, but in the human voice and the sacred trust placed in it. Long before writing became widespread, the primary vehicle for preserving complex information was the spoken word, refined into powerful oral traditions. These were not casual campfire stories. They were meticulously crafted repositories of knowledge, designed to be memorized and recited with absolute precision. Think of the epic poems of Homer, which preserved details of Greek culture and warfare for centuries before being written down. In a similar way, the principles of sacred geometry, the ratios, the alignments, the units of measure could have been encoded into songs, chants, or rhythmic poems. This method of transmission is far more robust than we might assume. When knowledge is set to a meter or a melody, it becomes easier to memorize and far more resistant to change over time. An apprentice builder wouldn't just learn a number, he would learn a verse that described a specific triangle in relation to the rising sun, embedding the mathematical rule within a practical, memorable context. This oral system created a living library, one that was carried in the minds of the initiated, but such precious knowledge would never have been public property. This is where the concept of secrecy comes in. It's highly likely that this geometric language was the guarded secret of a specialized class, a guild of master masons, a closed society of astronomer priests, or a lineage of families who held this wisdom as a sacred trust. These individuals would have been the ancient world's equivalent of Nobel Prize-winning scientists and master engineers combined. Their status and power depended on their exclusive command of the techniques that could raise cities and please the gods. To protect that power and ensure the purity of the knowledge, they would have shrouded it in layers of ritual and initiation. Admission into these inner circles would have been arduous, requiring years, perhaps decades, of apprenticeship. The knowledge would be passed down not in a single lecture, but through a slow, immersive process of doing. An apprentice would first spend years simply moving stones, learning the feel and fracture points of different rock types. Then he might graduate to shaping, learning the precise angles by hand and eye. Only after proving his dedication and skill would the deepest secrets, the meanings behind the proportions, the astronomical correlations, the spiritual symbolism, be whispered to him. This system of gradual revelation served two purposes. It protected the knowledge from the unworthy, and it ensured that the master truly understood the practical application of every theoretical principle. The geometry wasn't just abstract math, it was a lived experience. The fragility of this entire system, however, is obvious. It was a chain of memory, and that chain was vulnerable to being broken. Unlike a book that can sit on a shelf for 1,000 years and still be read, an oral tradition requires a continuous, unbroken line of teachers and students. A single catastrophe could sever that line forever. Imagine the impact of a great plague that decimates a population, taking with it the few elder masters who held the entire system in their minds. Consider a violent invasion by a culture with a different religion and no interest in preserving the old ways. The guilds would be scattered, their members killed or enslaved, their sacred sites desecrated. We know from history that societal collapses, like the Bronze Age collapse around 1200 before the Common Era, led to the disappearance of entire languages, technologies, and systems of government across the Mediterranean. In such a chaotic dark age, the meticulous preservation of geometric constants would be a low priority compared to simple survival. The knowledge of how to build a pyramid would be useless to a society struggling to grow enough food. The intricate chants would be forgotten, replaced by more immediate prayers for rain and safety. Another powerful force that could erase such a tradition is the rise of a new, dominant religion. The old gods to whom the temples were aligned would be declared demons or false idols. The knowledge associated with their worship could be systematically suppressed, its practitioners persecuted. The new priesthood would have no use for the complex geometric language of the old faith. Their power would be based on new scriptures, new rituals, a new orthodoxy. The master builders, if they survived at all, would have to go underground, perhaps embedding fragments of their knowledge into the architecture of the new religion's churches or mosques. but never again possessing the complete, unified system. The sacred language would become fragmented, its grammar lost, leaving behind only a few recognizable words in the form of recurring architectural motifs whose original meaning had faded into obscurity. This slow death by replacement might be even more effective than a sudden catastrophe, as it dismantles the tradition piece by piece over generations, until no one is left who remembers why certain proportions were considered sacred in the first place. The stones remain, but the voice that gave them meaning falls silent, leaving behind the very mystery we are trying to solve today. So we arrive at the ultimate question, the reason for this entire investigation. If these ancient structures truly form a sophisticated language written in stone and stars, what profound message were its creators trying to convey across the millennia? The silent stones offer no simple translation, but their consistent design points to several compelling and perhaps interconnected interpretations. One of the most urgent possibilities is that this geometry serves as a stark warning. Embedded within the precise alignments and enduring materials could be a record of a catastrophic event, a memory of a global cataclysm so devastating that the survivors were determined to preserve the knowledge for future generations. Think of the prevalence of flood myths in cultures worldwide, from the story of Noah in the Bible to the epic of Gilgamesh in Mesopotamia and the tales of Manu in Hindu scriptures. What if the consistent orientation of sights to cardinal directions and celestial cycles is not just about observation, but about marking a before and after? The structures themselves, built on high ground with incredible stability, could be models of survival designed to withstand the very forces that destroyed a previous world. The message in this light would be a dire one: civilization is fragile and the cosmos can reset the board. These monuments stand as permanent sentinels, reminding us that the stability we enjoy is not guaranteed, and that the knowledge of past disasters is our greatest shield against future ones. A second, deeply spiritual interpretation suggests that this geometric language is not a warning about the physical world, but a guide for the soul's journey through it and beyond. The very layout of these sites often mimics a path of initiation. Consider the long, dark passageway of Newgrange, leading to a chamber illuminated by the solstice sun. This is a powerful architectural metaphor for the journey from the darkness of ignorance to the light of enlightenment. The complex interplay of squares representing the earthly realm and circles symbolizing the divine could be a map for spiritual ascent. The pyramid, with its square base reaching a celestial point, is a perfect illustration of this idea. The human spirit rising from its material confines to achieve union with the cosmos. In this view, the monuments were more than temples, they were functional machines for consciousness. The specific resonant frequencies found in their chambers, which we will explore later, might have been designed to alter brainwave states, facilitating visions or meditative trances. The message, then, is one of hope and instruction. It says that within the geometry of creation lies a coded pathway for transformation, a set of instructions for the human soul to recognize its own divine nature and navigate the afterlife. The builders weren't just concerned with this life, they were building a bridge to the next, on a more practical yet equally brilliant level. The language could be a vast repository of essential data, a Stone Age library designed to preserve civilization-critical information. In a world without hard drives or printed books, how do you safeguard the knowledge needed for survival and progress? You encode it into the landscape on a scale that cannot be lost, corrupted, or easily destroyed. The astronomical alignments function as a permanent, fail-safe calendar. Knowing the exact timing of the solstices and equinoxes was not abstract science. It was the key to agricultural success, dictating when to plant and when to harvest. This knowledge meant the difference between feast and famine. For a seafaring culture, the stars were a GPS. The precise orientations of certain sites to specific stars, like the connection between the Great Pyramid and Orion's belt, could have served as navigational markers, guiding voyages across vast oceans. The very dimensions of the structures might encode standard units of measurement, ensuring consistency in trade and construction across great distances and time. This interpretation paints the builders as pragmatic geniuses, creating a backup of their entire operating system in the most durable medium imaginable. The message is one of stewardship. Here is the knowledge to build a society, to feed your people, and to navigate your world, protect it. Perhaps the most profound interpretation of all transcends practical warnings, spiritual guides, or data storage. It suggests that the ultimate message is a philosophical one, a testament to the fundamental unity of all knowledge and the interconnectedness of the cosmos. The recurring appearance of irrational numbers like pi and phi, numbers that govern the shape of galaxies, the structure of atoms, and the growth of living things, implies that the builders understood a deep truth. The same mathematical principles apply at every scale of existence. By building structures that mirrored these constants, they were making a bold statement about the nature of reality. They were demonstrating that there is no separation between the sacred and the scientific, between the spiritual and the physical. The universe is a single, coherent, and intelligible whole. The pyramid is a mountain and a star map. The stone circle is a calendar and a model of atomic structure. This holistic worldview is a radical departure from our modern tendency to compartmentalize knowledge into separate disciplines like physics, biology, and theology. The message embedded in the geometry is an invitation to rediscover this unity. It is a call to recognize that the same force that curves the planets in their orbits also shapes the shell of a snail, and that humanity is an integral part of this magnificent geometric tapestry. The silent language of the giants, therefore, may not be a complex sentence to be decoded, but a simple, elegant truth to be felt, that we are not alone in the universe because we are, in fact, made of the same stuff as the stars, and the code for existence is written in the stones beneath our feet and the heavens above our heads. Of course, the theories we've explored so far are captivating, suggesting a lost global language and the hands of advanced giants. But a truly responsible investigation requires us to step back and listen to the other side of the debate, to the voices of mainstream archaeology and skeptical science. These perspectives offer a very different yet equally fascinating narrative, one that attributes these wonders not to mysterious outsiders, but to the sheer, unadulterated genius of our own human ancestors. This viewpoint asks a fundamental question: are we searching for answers in the stars because we find it difficult to believe what humanity is capable of achieving on its own? At the heart of the skeptical argument lies a powerful principle of logic known as Occam's razor. Simply put, this principle suggests that when faced with multiple explanations for a phenomenon, the simplest one that requires the fewest assumptions is usually the correct one. Let's apply this to the mystery of the megaliths. Explanation 1. A highly advanced global civilization of giants or master builders existed in prehistory, possessed a universal geometric language, orchestrated the construction of incredible monuments worldwide, and then vanished without a clear trace, leaving behind only these structures. This explanation is dramatic and compelling, but it requires us to make a cascade of big assumptions about lost history. Now consider explanation 2. Human beings, through observation, experimentation, and the gradual accumulation of knowledge over countless generations, developed sophisticated engineering techniques and an empirical understanding of geometry and astronomy, which they applied to their most important projects. This explanation may seem less thrilling, but it relies on processes we can observe throughout human history: ingenuity, collaboration, and slow, steady progress. Occam's razor would guide us toward the second explanation, not because it's certain, but because it is more parsimonious, requiring fewer leaps of faith. Mainstream archaeology points to a wealth of evidence that demonstrates this gradual development of skill. The pyramids of Giza did not appear out of nowhere. They are the magnificent culmination of a long, visible evolutionary process. If you travel to Saqqara, just south of Giza, you can see the step pyramid of Pharaoh Djoser, designed by the legendary architect Imhotep. This structure is clearly a prototype, an early attempt at large-scale stone construction that shows both ambition and a learning curve. Even earlier, at sites like Abydos, we find royal tombs that began as simple pits in the ground, evolving over time into more complex mud-brick structures called mastabas. This is a clear archaeological record of trial and error, of each generation of builders standing on the shoulders of the last, refining their techniques, learning from their mistakes, and pushing the boundaries of what was possible. There were no instant masters. There was a centuries-long journey of improvement. This pattern repeats across the world. The stunning perfection of the Inca walls at Saxehuaman is preceded by older, cruder examples of stonework, showing a clear progression in skill. The first Moai on Easter Island are smaller and less refined than the later, colossal statues. This evidence strongly suggests that what we are seeing is not a sudden injection of advanced knowledge, but the peak of a long, indigenous technological curve. When it comes to the mind-boggling precision, skeptics argue that we consistently underestimate the power of empirical knowledge. That is, knowledge gained through direct, practical experience rather than theoretical science. A builder doesn't need to know the abstract mathematical formula for pi to understand circular relationships. If you take a wheel and roll it one full revolution, the distance it travels is its circumference, which is pi times its diameter. An ancient engineer working with ropes and wheels could have easily discovered this relationship through simple experimentation. Similarly, the golden ratio, or phi, is not just a number, it is a proportion that is inherently pleasing to the human eye. Artists and architects throughout history have gravitated towards it intuitively because it looks right. A master carpenter can create a perfectly proportioned piece of furniture without ever calculating a mathematical constant. He uses his trained eye and a lifetime of experience. The builders of the Parthenon or the Great Pyramid were likely applying a deep, culturally ingrained sense of proportion and harmony, refined over generations of practice. Their tools may have been simple cord stakes, sighting rods, and plumb bobs, but in the hands of a true expert, these tools are incredibly precise. The argument is that their skill was not in knowing complex equations, but in mastering the practical application of simple principles on a grand scale. Furthermore, the idea of a single, global source for this knowledge faces significant logistical and cultural hurdles. If a worldwide civilization or a traveling group of master builders was responsible for spreading these techniques, we would expect to find much more than just architectural similarities. We would expect to see evidence of cultural exchange, similar pottery styles, related languages, shared artistic motifs, or the remains of trade goods in archaeological layers. Yet the cultures that built the pyramids of Egypt, the ziggurats of Mesopotamia, and the temples of Mesoamerica were profoundly different. Their religious beliefs, social structures, languages, and daily lives show no clear signs of a common origin. The pyramids of Egypt were smooth-sided tombs for god-kings, focused on the afterlife. The ziggurats of Mesopotamia were stepped temples, meant to be climbed for rituals. The Mesoamerican pyramids were often platforms for temples and human sacrifice, with steep stairways reaching for the sky. The form is superficially similar, but the function and meaning are worlds apart. This suggests independent invention driven by a common human response to similar challenges and aspirations, rather than direct instruction from a central source. Finally, and perhaps most importantly, the conventional perspective argues that attributing these achievements to lost civilizations or non-human giants does a profound disservice to our ancestors. It robs them of their rightful legacy. It implies that the ancient Egyptians, the Maya, the Neolithic Britons, and the Rapa Nui people were incapable of such greatness on their own, that they needed outside help to create their own cultural masterpieces. This viewpoint can be seen as a form of modern arrogance, a refusal to grant ancient peoples the same capacity for intelligence, innovation, and collaborative achievement that we pride ourselves on today. The truly awe-inspiring idea may not be that aliens or giants built these structures, but that human beings, with their hands, their minds, and their unwavering determination, accomplished these feats. It speaks to a universal human potential that, when harnessed by a united society with a powerful purpose, can literally move mountains and reshape the landscape in accordance with their understanding of the cosmos. So, while the mystery of the how remains, the skeptical view offers a powerful and respectful conclusion. We are not looking at the ruins of a forgotten superior race, but at the magnificent testament of our own human family, a reminder of what we are capable of when we set our minds to a task that transcends the individual and reaches for the eternal. For centuries, our understanding of ancient sites was limited to what we could see on the surface, like trying to read a book by only looking at its cover. Archaeologists relied on painstaking excavation, a process that is not only slow and laborious but also inherently destructive. Digging through layers of history can inadvertently erase the very context it seeks to understand. But today, a technological revolution is quietly unfolding, granting us a kind of X-ray vision that allows us to peer into the past without ever lifting a shovel. This new era of discovery is being driven by two powerful tools, LiDAR and ground-penetrating radar, and they are fundamentally changing the conversation about the scale and sophistication of ancient civilizations. Let's start with LiDAR, which stands for light detection and ranging. Imagine flying over a dense, impenetrable rainforest in a small aircraft equipped with a laser scanner. This device fires millions of rapid laser pulses down toward the ground. Most of these pulses are reflected back by the leaves and branches of the canopy, but a fortunate few slip through tiny gaps and hit the solid ground below. By measuring the minute difference in time it takes for each pulse to return, and using GPS to precisely track the aircraft's position, a powerful computer can filter out the vegetation and generate an astonishingly detailed, three-dimensional map of the bare Earth. It's like digitally deforesting an entire landscape in a matter of hours, revealing a hidden world that has been invisible for 1,000 years. The impact of this technology has been nothing short of revolutionary, particularly in places like Central America. For generations, archaeologists believed that the ancient Maya lived in scattered, isolated city-states surrounded by untamed jungle. But when LiDAR was deployed over the forests of Guatemala, it revealed a breathtaking truth. The jungle floor was not empty. It was crisscrossed with a vast network of raised highways, sophisticated irrigation canals, and intricate terracing for agriculture. It showed that what were thought to be independent cities like Tikal were actually connected parts of a sprawling, densely populated metropolis. The scale of construction was far greater than anyone had imagined, suggesting a level of social organization, engineering, and population density that rivals ancient civilizations anywhere in the world. This single technological leap forced a complete rewrite of Maya history, proving their society was far more complex, interconnected, and advanced than we ever knew. But LiDAR's revelations don't stop there. By revealing the full extent of these ancient landscapes, it allows researchers to see the grand, overarching design. They can now analyze the spatial relationships between structures, pyramids, and causeways on a regional scale. This is where our geometric language theory finds new fuel. With a complete map, archaeologists can search for large-scale geometric patterns that were impossible to detect from the ground. Are these cities laid out according to a celestial grid? Do the roads between them form specific sacred shapes or align with astronomical events? LiDAR provides the raw data to ask these questions in a way that was never before possible, potentially uncovering a regional master plan governed by the same principles of sacred geometry we see in individual structures. While LiDAR excels at stripping away vegetation from above, ground-penetrating radar, or GPR, is the master of seeing what lies beneath our feet. This technology works by sending high-frequency radio waves into the ground. When these waves encounter a change in material, like the interface between soil and a buried stone wall, or an empty tomb chamber, they bounce back to a receiving antenna. By towing a GPR unit over a site, archaeologists can create a detailed subsurface profile, essentially a sonogram of the Earth. This allows them to map entire foundations, locate buried chambers, and identify ancient pits or hearths without any digging. It's a non-invasive way to explore a site's hidden anatomy. The applications for our geometric mystery are profound. At a place like Stonehenge, where the visible stones are just the skeleton of a much larger complex, GPR has been instrumental. Surveys have revealed a stunning array of previously unknown post holes, burial mounds, and processional pathways surrounding the famous circle. This shows that Stonehenge was not a standalone monument but the heart of a vast ceremonial landscape. Similarly, GPR scans around the pyramids of Giza have hinted at the possibility of unexplored chambers and voids deep within the bedrock, suggesting that even our most studied sites may still hold profound secrets. For the theory of a universal language, this is critical. If a hidden chamber were to be discovered that contains artifacts linking the building techniques or beliefs of different cultures, it would be a game changer. GPR gives us the ability to target our explorations with surgical precision, focusing on the most promising areas that might hold the equivalent of a Rosetta Stone for this architectural code. Together, these technologies are acting as a force multiplier for archaeological research. They allow small teams to survey enormous areas in a fraction of the time, making discoveries that would have taken generations of traditional digging. More importantly, they are adding a new dimension of data to the debate between mainstream and alternative history. The sheer scale of urban planning revealed by LiDAR makes the idea of simple, primitive societies increasingly difficult to sustain. It forces us to confront the reality of advanced, continent-wide civilizations with the logistical capability to reshape their entire environment. The hidden structures revealed by GPR suggest that our current understanding of these sites is incomplete, that there are layers of meaning and construction still waiting to be interpreted. This influx of new data doesn't automatically prove the existence of a lost global language or a race of giants, but it dramatically raises the stakes. It shows that the ancient world was far more complex, interconnected, and engineered than we ever documented. Every new hidden city mapped by LiDAR, every new chamber detected by GPR, adds another piece to the puzzle. They are providing the hard evidence that allows us to move beyond speculation and into a more nuanced, data-driven investigation. The stones have been silent for millennia, but now, with these technological ears, we are finally beginning to hear their whispers, and they are telling us that the story of our past is far grander and more mysterious than we ever dreamed. The silent language of the megaliths may have faded from common knowledge, but its echoes never truly vanished. Instead, they went underground, flowing like a hidden river through the secret streams of esoteric thought and spiritual practice, resurfacing centuries later in the most unexpected of places. The core idea that geometry is a divine code, a key to unlocking the secrets of the cosmos, proved too powerful to be lost entirely. It was preserved and transformed by mystical traditions that recognized its profound power, becoming a central pillar in movements that sought to bridge the gap between the material world and the spiritual realm. One of the most significant revivals occurred during the intellectual and artistic explosion of the European Renaissance. As scholars rediscovered ancient Greek and Roman texts, they also encountered a body of wisdom attributed to the mythical sage Hermes Trismegistus, a fusion of the Greek god Hermes and the Egyptian god Thoth. This Hermetic tradition, as it came to be known, was built on the principle of as above, so below, the very same concept we saw encoded in the celestial alignments of ancient sites. Renaissance magi, figures like Marsilio Ficino and Giordano Bruno, believed that the universe was an interconnected whole, a great chain of being governed by mathematical laws. To them, geometry was not just a practical tool for artists like Leonardo da Vinci, who used the golden ratio to create his perfectly proportioned Vitruvian Man. It was a form of magic. By understanding and manipulating these sacred shapes and proportions, the Hermetic philosopher sought to draw down the influences of the heavenly spheres, to understand the mind of God through the language of mathematics. This was a direct intellectual descendant of the megalithic worldview, where building a structure in harmony with cosmic principles was an act of participating in divine creation. Perhaps the most visible modern inheritors of this geometric legacy are the Freemasons. While their origins are shrouded in the myths of medieval stoneworker guilds, their symbolism is a veritable lexicon of sacred geometry. The most iconic Masonic emblem is the square and compass, tools that are far more than simple implements. The square represents morality, fairness, and the material world. It is the builder's tool for creating perfect right angles, echoing the ancient symbolism of the square as the earthly domain. The compass, used to draw circles, symbolizes spirituality, the divine, and the boundless nature of the soul. When interlaced, they represent the perfect balance between the earthly and the celestial, the very same harmony that the pyramid builders sought between their square base and celestial apex. Freemasonic lodges are often designed with precise geometric proportions, and their rituals are filled with references to the construction of Solomon's Temple, a symbolic edifice representing the perfection of the human soul. For Masons, the process of becoming a master builder is an internal spiritual journey of squaring one's own rough ashlar, the imperfect self, into a perfect cubic stone ready to be placed in the great cosmic temple. This is a powerful metaphor that directly translates the external, architectural language of the ancients into an internal blueprint for personal enlightenment. This fascination with geometric order as an expression of the divine is not unique to the West. In the Islamic world, where religious tradition often discourages the depiction of figurative images in sacred spaces, geometry became the primary visual language for conveying spiritual truths. Step inside any great mosque, from the Alhambra in Spain to the Shah Mosque in Iran, and you will be enveloped by an awe-inspiring tapestry of intricate patterns. These are not random decorations, they are profound theological statements. Complex star patterns, interlacing circles, and endless knots, known as jiri, cover the walls and domes. These patterns are often based on the repeated division of the circle, symbolizing the unity and infinite nature of God, or Allah. The fact that these designs can extend infinitely in all directions without a beginning or an end is a direct representation of God's omnipresence and eternity. The meticulous craftsmanship required to create these patterns reflects the order and intelligence of the created universe. In Islamic art, geometry is a form of prayer, a way for the artist to participate in the divine act of creation by imposing beautiful, intelligent order onto matter, mirroring the cosmic principles they believe govern all of existence. Finally, we can look to the soaring architecture of the great Gothic cathedrals of medieval Europe. Structures like Chartres Cathedral or Notre Dame de Paris are often seen as triumphs of faith, but they are equally triumphs of a hidden geometric science. The master masons who designed them employed the same sacred ratios we find in much older sites. The floor plans of these cathedrals are often based on the geometry of the square and the circle, and their elevations frequently incorporate the golden ratio, creating proportions that are instinctively harmonious to the human spirit. The great rose windows, with their intricate tracery radiating from a central point, are not just stunning feats of engineering, they are massive, luminous mandalas. They filter divine light into the sacred space, transforming sunlight into a kaleidoscope of color, much like the polished casing stones of the Great Pyramid would have reflected the sun's rays. The entire structure of a Gothic cathedral, with its pointed arches reaching for the heavens and its layout designed as a cross, is a geometric map of the Christian cosmos, guiding the worshipper on a spiritual journey from the nave toward the altar. It is a three-dimensional sermon written in stone and light, using a vocabulary of shape and proportion that would have been intimately familiar on some deep level to the builders of Stonehenge. This unbroken thread, weaving from the Neolithic stone circles to the Renaissance study rooms and onto the spires of Chartres, reveals a perennial human intuition that the universe is built on a geometric foundation, and that by understanding its language, we can come closer to understanding the architect of it all. But what if the source of this incredible geometric code isn't a lost civilization at all, but a teacher that has been with us all along, written into the very landscape of our planet? To find the origins of this silent language, we might not need to look to the stars or dig for buried cities, but simply to observe the world around us with fresh eyes. There is a profound and beautiful possibility that the ancient builders were not inventing a new language, but were instead learning to speak the native tongue of nature itself, translating the mathematical patterns of the natural world into stone. Consider one of the most striking examples of nature's own architecture, the Giant's Causeway in Northern Ireland. Here, thousands of interlocking basalt columns rise from the sea, forming a pavement of perfect hexagons that look so meticulously crafted it seems artificial. This phenomenal structure was created by the cooling and cracking of molten lava, a purely physical process following the immutable laws of thermodynamics. As the lava cooled, it contracted, and the most efficient way to release the stress was to fracture into hexagonal shapes, creating the path of least resistance. This same pattern of hexagonal packing appears in beehives, where bees instinctively build their honeycombs in this configuration because it uses the least amount of wax to create the most storage space. It is a lesson in structural efficiency written in rock and wax. Now, travel across the world to the polygonal masonry of Saxehuaman in Peru or the foundations of Mycenaean cities in Greece. The stones are cut into complex, multi-angled shapes that fit together with breathtaking precision. While not perfectly hexagonal, the principle is eerily similar, an interlocking pattern that creates immense strength and stability without the need for mortar. It's as if the human masons were observing the natural strength of basalt columns and applying the same engineering principle to their own walls, learning from the planet how to build for eternity. This mimicry extends beyond static forms into the dynamic, repeating patterns known as fractals. A fractal is a shape that appears similar at different scales. Zoom in on a part of it, and you'll see a pattern that echoes the whole. We see this all around us in the branching of a tree, where a large limb splits into smaller branches, which then split into twigs, following the same basic pattern over and over. We see it in the intricate veins of a leaf, in the forked paths of a lightning bolt, and in the sprawling, recursive structure of a river delta. These are not random designs. They are the result of efficient systems for distributing energy, nutrients, or water. Now look at ancient art and decoration. The intricate, labyrinthine spirals carved into the stones of Newgrange are not just abstract art. They are a direct reflection of fractal patterns found in nature, from the spiral of a snail's shell to the swirling formation of a galaxy. In Islamic art, the complex geometric designs known as arabesques often feature recursive patterns that repeat and scale down infinitely, creating a visual representation of the infinite complexity of God's creation. The ancient artists were not just making pretty designs, they were encoding a fundamental observation about the nature of reality, that the same patterns repeat at every level of existence, from the microscopic to the cosmic. This connection becomes even more compelling when we consider the most famous ratio of all, the golden ratio, or phi. We find this proportion, approximately 1.618, meticulously used in the Parthenon and the Great Pyramid. But where did the builders first encounter it? They encountered it every time they walked through a forest. The arrangement of leaves around a stem often follows a pattern based on phi, allowing each leaf to maximize its exposure to sunlight without shading the ones below. They saw it in the seed head of a sunflower, where the seeds are arranged in opposing spirals, and the number of spirals in each direction are consecutive Fibonacci numbers, a sequence whose ratios approach phi. They saw it in the elegant curve of a nautilus shell, where each new chamber grows in proportion to the last by this same ratio. These are not just aesthetic accidents, they are the result of optimal growth patterns, the most efficient way for an organism to develop. By incorporating phi into their architecture, the ancients were not imposing an arbitrary standard of beauty. They were aligning their creations with the most efficient and pervasive growth principle in the natural world. They were building in a way that felt inherently right because it resonated with the deep, subconscious recognition of a pattern that is fundamental to life itself. This idea leads us to a truly revolutionary thought. What we call sacred geometry might not be a human invention at all. Instead, it could be the observable framework of the universe, a set of physical and mathematical constants that govern everything from the orbit of planets to the structure of a crystal. The builders were not mystics hiding secrets. They were the first physicists, the first systems biologists, carefully observing their environment and deducing its operating principles. The perfect alignment of a structure to the solstice sun is simply an acknowledgement of a celestial clock that has been ticking for billions of years. The use of pi in a pyramid's dimensions is an homage to the circle, the fundamental shape of orbits and atoms. In this light, the ancient monuments become less like cryptic messages and more like scientific models, three-dimensional textbooks recording humanity's earliest understanding of universal laws. This perspective fundamentally strengthens the argument for a universal language. If the language is not a human cultural construct, but is instead the native language of physics and biology, then it makes perfect sense that isolated cultures around the world would eventually discover it. A brilliant mind studying the stars in Egypt will deduce the same circular nature of celestial motion as a brilliant mind studying the stars in Mesoamerica. A master mason experimenting with stone in Peru will discover the same principles of stable, interlocking construction as a mason in Japan. They are all reading from the same source material, the natural world. The consistency we see in ancient sites, therefore, is not necessarily proof of direct contact, but rather compelling evidence for a shared reality. Different cultures in different times and places were independently learning to speak the same cosmic language because they were all studying the same text, the universe itself. The silent, geometric harmony we perceive in these ancient wonders is then the deepest kind of harmony possible, a resonance between human creativity and the fundamental mathematical order of nature. There is a reason why these ancient builders chose to work on a scale that defies easy comprehension. It wasn't merely a demonstration of what was technically possible, it was a calculated act of psychological engineering. Imagine yourself as a traveler in the ancient world, approaching the Giza plateau for the first time. After weeks of journey through the monotonous desert, the pyramids would have appeared not just as structures, but as impossible mountains of white, gleaming stone, their peaks seemingly scratching the underside of the sky. Your entire frame of reference would have been shattered. The ordinary human scale of your home, your village, even the local temple, would have been rendered utterly insignificant in an instant. This overwhelming sensation, this feeling of being dwarfed and humbled in the presence of something vastly greater than yourself, has a name: awe, and awe is one of the most powerful tools for shaping human thought and behavior. This deliberate use of scale to induce awe is a universal language in itself, one that speaks directly to our primal instincts. When we encounter something of immense size, our brain's threat detection system can be triggered in a controlled way. It's not the panic of immediate danger, but a profound sense of reverence and, at times, a touch of fear. This emotional cocktail is incredibly effective at commanding respect and submission. For the ruling class or the priestly elite who commissioned these monuments, this was a masterstroke of social control. By constructing edifices that physically and psychologically dominated the landscape, they were broadcasting an unambiguous message about their own power and their special connection to the divine. The unspoken statement was clear: the beings who commanded this work, whether pharaohs or gods, operate on a level so far beyond your own that your only appropriate response is obedience and reverence. The architecture itself becomes a form of non-verbal authority, a permanent assertion of power that requires no words, no soldiers, just the silent, crushing weight of its own existence. Beyond political control, this manipulation of scale was fundamental to creating a sacred space, a zone utterly separate from the profane world of everyday life. The journey to a site like the Great Pyramid was not a casual stroll. The massive causeways, the towering walls, the need to navigate a carefully planned path, all of it was designed to create a ritual of transition. As you moved from the open desert into the shadow of the monument, you were leaving the mundane behind. The sheer size of the stones underfoot, the towering walls beside you, and the immense structure looming above worked in concert to narrow your focus, to turn your attention inward and upward. The chatter of daily life would have fallen away, replaced by a hushed solemnity. This sensory deprivation and reorientation is a classic technique for inducing altered states of consciousness. The architecture functions as a psychological filter, preparing the visitor for a spiritual encounter by first overwhelming their ordinary sense of self. This is where the geometry we've discussed earlier performs its most elegant dance with sheer scale. The proportions are not just an intellectual code, they are a felt experience. The perfect squares and triangles, the harmonious ratios, provide a subconscious sense of order and stability that counterbalances the potentially frightening aspect of the immense size. While the scale of the pyramid humbles you, its precise geometry reassures you. It tells your subconscious mind that this overwhelming power is not chaotic or malevolent, but is instead governed by a deep, intelligent, and benevolent order. The combination is devastatingly effective. The scale shatters your ego and opens your mind, while the geometry guides that opened mind toward a perception of cosmic harmony. It's a one-two punch of psychological design, first creating a vacuum of understanding and then filling it with a specific, awe-inspiring vision of the universe. We can see this principle at work across cultures and epochs. The same feeling of awe and humility that a Neolithic person felt at Stonehenge is replicated centuries later when a Christian pilgrim first gazed upon the soaring vaults of a Gothic cathedral. Those immense stone-ribbed ceilings, reaching seemingly impossible heights, were designed to lift the eyes and the soul heavenward, to make the worshipper feel both insignificant in the face of God's glory and yet intimately connected to the divine through the beauty of the space. The architects understood that to inspire spiritual transcendence, they first had to architecturally transcend the ordinary human experience. This psychological impact extends to the very act of creation. For the society that built these monuments, the decades or even centuries of labor involved were not just an economic undertaking, they were a continuous collective ritual. The process of building something so vast, so beyond any single lifetime, would have instilled a powerful sense of purpose and identity. It bound the community together in a shared, sacred project, reinforcing social cohesion and creating a tangible legacy that connected them to their gods and their ancestors. The psychological message for the builders themselves was one of participation in something eternal. While the finished product awed the visitor, the act of construction forged the builder, embedding the geometric and spiritual principles of the design into the very culture through generations of hands-on work. The monument, therefore, was not just a static object to be viewed, but a dynamic engine for psychological and social transformation, affecting everyone who interacted with it, from the lowliest laborer to the most exalted priest, for centuries on end. While the colossal stone monuments offer a three-dimensional testament to this potential global language, the message may not have been confined to architecture alone. If a worldwide network of knowledge truly existed, its signature should also be visible in more portable forms of expression, in the art and cartography that could be carried across continents. Here we shift our gaze from the monumental to the miniature, searching for the same geometric code etched onto cave walls, pottery, and even ancient maps, suggesting a shared symbolic vocabulary that traveled as easily as a trader's pack. One of the most tantalizing pieces of evidence comes from an unexpected source, a map drawn in 1513 by an Ottoman admiral named Piri Reis. The map itself is a fascinating document, but it's a note in the admiral's own handwriting that has sparked centuries of debate. He wrote that he compiled his map from numerous source charts, including some that dated back to the time of Alexander the Great. The most controversial section of the map depicts the Atlantic Ocean and the western coast of Africa, but it also seems to show a landmass to the far south with unusual accuracy, a coastline that some researchers argue bears a striking resemblance to the continent of Antarctica. This is problematic because Antarctica was not officially discovered until 1820, and its coastline is now buried under miles of ice. How could a 16th century mapmaker have known its shape? The mainstream explanation is that the depicted land is likely a composite of speculative geography and the distorted coast of South America. However, proponents of advanced ancient knowledge suggest that the Piri Reis map is a copy of a copy, a relic from a much older, sophisticated seafaring civilization that possessed the geographic knowledge to map the world, including ice-free coastal regions of Antarctica from a remote epoch. Whether it's a cartographic miracle or a misinterpreted coincidence, the map forces us to consider the possibility that our picture of ancient exploration is dramatically incomplete. Beyond maps, we can look to the oldest human canvases, the walls of caves and exposed rock faces, scattered across the globe from the caves of Lascaux in France to the deserts of the American Southwest, are ancient petroglyphs and pictographs that feature a recurring set of symbols. Spirals, concentric circles, zigzag lines, and intricate grids appear again and again, often separated by thousands of miles and thousands of years. At first glance, these might seem like simple decorations, the doodles of prehistoric people. But when viewed through the lens of a geometric language, they take on a deeper significance. A spiral is not just a spiral, it is a representation of the journey of the sun, the growth pattern of a shell, the swirling vortex of a galaxy, or the cyclical nature of time itself. Concentric circles might represent the layers of the world, from the inner self to the outer cosmos, or ripples of energy emanating from a central source. These symbols are a simplified, essentialized form of the same principles encoded in the megaliths. They are the basic alphabet of this potential language, easy to carve and remember, allowing a shaman in Europe and a shaman in North America to conceptually align with the same understanding of cosmic order without ever meeting. This symbolic consistency becomes even more pronounced when we examine the intricate designs on ancient pottery. In the Neolithic Vinca culture of southeastern Europe, pottery fragments are inscribed with a series of symbols that some have controversially called the Vinca script, though it likely represents a proto-writing system of ideograms. Among these symbols are spirals, meanders, and branching patterns that strongly resemble the fractal designs we see in nature. Similarly, the pottery of the ancient Mimbres culture in the American Southwest often features complex geometric patterns, with spirals and stepped frets that mirror the architectural motifs found in their pueblos and kivas. These weren't just aesthetic choices, they were a way of embedding sacred geometry into everyday objects, infusing a water jar or a food bowl with symbolic power, and connecting the mundane act of drinking or eating to the larger cosmic patterns. The portability of pottery meant that these symbols could travel along trade routes, spreading a shared visual language far and wide. What emerges from this survey of two-dimensional art is a pattern of profound consistency. The same geometric motifs, the spiral, the circle, the grid, appear as a universal visual vocabulary. This is not necessarily proof of direct contact, but it is powerful evidence for a shared human intuition about the fundamental patterns that underlie reality. Just as different cultures independently discovered that a roof needs a certain pitch to shed rain, they may have independently recognized that certain shapes hold a deep, symbolic resonance. These shapes are the building blocks of perception, the forms that our minds naturally gravitate towards when trying to make sense of the world. The ancient artists were perhaps giving form to these deep-seated psychological archetypes, creating a visual language that was universally understandable because it was rooted in the shared experience of being human and observing the same natural world. Whether transmitted across continents or bubbling up from a collective unconscious, this recurring geometric code in art and maps suggests that the language of the giants was not locked in stone, but was a living, breathing system of thought that permeated every aspect of ancient life, from the grandest temple to the humblest clay pot. This idea of a great and sudden forgetting leads us to one of the most dramatic and controversial explanations for the loss of this potential global language: the possibility of a planetary cataclysm. If a sophisticated network of knowledge truly did span the globe in the deep past, its disappearance would require an event of corresponding scale, something so devastating that it could fragment a civilization, shatter its institutions, and reduce survivors to a desperate struggle for mere survival. The sheer perfection and sudden appearance of these ancient wonders, followed by a long period of technological decline, fits a pattern that looks remarkably like the aftermath of a disaster. It is a scenario written not in stone, but in the myths and geological records of our planet. The most scientifically grounded of these cataclysm theories is the Younger Dryas impact hypothesis. This theory proposes that around 12,800 years ago, as the last ice age was retreating and the world was warming, a catastrophic event abruptly reversed the trend. The hypothesis suggests that one or more fragments of a large comet entered Earth's atmosphere and exploded over North America or impacted the ice sheet covering it. The immediate effects would have been apocalyptic. The airbursts would have generated immense fireballs, igniting continent-wide wildfires. The subsequent impact on the ice sheet would have unleashed colossal floods of meltwater into the oceans. But the most devastating consequence would have been the climatic effect. The immense amount of dust, soot, and water vapor thrown into the atmosphere would have blocked out the sun, triggering a sudden, severe global cooling event known as the Younger Dryas period, which lasted for over 1,000 years. This was not a gradual change, it was a climatic car crash. Ecosystems that were just beginning to recover from the Ice Age were plunged back into a deep freeze. For any complex society dependent on agriculture, stable coastlines, and predictable seasons, this would have been an extinction-level event. Cities, ports, and agricultural centers would have been obliterated by fires and floods, and the survivors would have faced a world plunged into a long, dark winter. In such a scenario, the intricate knowledge of geometry, astronomy, and engineering would have become a useless luxury. The priority would shift from building for the stars to simply finding food and shelter. The great library of a global civilization wouldn't have been burned, it would have been frozen, and its librarians scattered to the winds. This scientific hypothesis finds a powerful echo in the most persistent and universal of all human myths, the story of the Great Flood. From the Mesopotamian epic of Gilgamesh to the biblical account of Noah, from the Hindu story of Manu to the flood legends of the indigenous peoples of the Americas, the narrative is strikingly consistent. A warning is given to a righteous individual, a great vessel is built, a cataclysmic deluge destroys the world of old, and the survivors are left to repopulate a cleansed but devastated earth. The ubiquity of this story is staggering. It appears in over 200 different cultures across every inhabited continent. While skeptics argue that flood myths are a natural product of human existence near rivers and coastlines, the consistency of the core elements, the divine warning, the ark, the saving of animal species, suggests a shared memory of a real, traumatic event of global proportions. The Younger Dryas event, with its massive meltwater pulses raising sea levels by hundreds of feet, provides a plausible geological mechanism for such widespread flooding. Coastal civilizations, which are often the most advanced, would have been erased almost overnight, their lands submerged beneath the rising waves. The message of these myths aligns perfectly with the cataclysm theory. A highly developed world was wiped away by water, and only a handful of people carrying fragments of the old knowledge survived to tell the tale. The advanced language of geometry was lost at sea, and all that remained were the stories of the flood and the towering, enigmatic structures built on high ground that somehow withstood the deluge. Beyond impacts and floods, our planet itself holds evidence of extreme instability. The field of geology reveals a history punctuated by massive volcanic events, known as super eruptions. An eruption like the one that created the Lake Toba caldera in Indonesia around 74,000 years ago is believed to have caused a global volcanic winter that lasted for years, pushing humanity to the brink of extinction. While this event is much older than the time frame for most megalithic building, it demonstrates the planet's capacity for sudden, dramatic change. Similarly, evidence suggests periods of rapid pole shift, where the Earth's magnetic field weakens and the magnetic poles can wander or even flip. While a physical shift of the geographic poles is debated, a rapid magnetic reversal could have devastating consequences, temporarily collapsing the magnetosphere that protects us from solar and cosmic radiation. This would have led to increased radiation levels on the surface, causing widespread illness and genetic damage, and potentially triggering climate chaos by allowing solar winds to strip away parts of the atmosphere. For an advanced civilization, such an event would corrupt any technology reliant on electronics, but even for an ancient society, the environmental and health effects would be catastrophic. The sky would appear to be falling, the sun would behave strangely, and navigation by the stars would become impossible. A culture that built its identity around celestial order would see its entire cosmological understanding shattered overnight. The aftermath of such a catastrophe provides the final, crucial piece of the puzzle. Imagine the survivors, the few who made it through the fires, the floods, the freezing cold, or the radioactive skies. They are not the scholars, the architects, or the astronomers. They are the hardy, the practical, those who knew how to hunt, to find clean water, to build a simple shelter. The intricate knowledge of Pi and Phi, the precise star charts, the secrets of moving 100-ton stones, these are no longer relevant. This advanced knowledge becomes a burden, a memory of a world that is gone. The survivors become preoccupied with the immediate tasks of survival. Over generations, the old stories become simplified, distorted into myths of gods and giants. The techniques for working stone are reduced to the bare essentials needed for basic construction. The global network is severed, and isolated pockets of humanity develop in their own directions, their cultures branching off from a common root but losing the connection to the sophisticated trunk. The great structures left behind by the precursor civilization would have been seen by these new societies with a mixture of awe and terror. They were clearly the work of gods or a race of giants, impossibly advanced beings from a lost age of wonders. The new inhabitants might even reuse the sites, building their own simpler temples upon the ancient, indestructible foundations, without any understanding of the profound science encoded within them. The language wasn't erased by malice or stupidity. It was simply drowned out by the desperate noise of starting over from scratch. The stones remained, but the key to their meaning was carried away in the minds of the last initiates, who took it to their graves in a world that had no use for it anymore. Of course, the ideas of a lost global language and a race of builder giants are powerfully alluring, and it's no surprise that they have exploded beyond academic journals and into the vibrant, often chaotic, arena of popular culture. This journey into the mainstream has been a double-edged sword, bringing global attention to these ancient mysteries while often blurring the crucial line between speculative theory and sensationalized fantasy. Perhaps no single television show has come to embody this phenomenon more than the long-running series Ancient Aliens, with its iconic tagline, "Could it be?" The show has presented a vast array of archaeological anomalies to a massive audience, frequently proposing extraterrestrial intervention as the most plausible explanation for humanity's ancient wonders. The show's format, featuring dramatic reenactments and a rotating panel of proponents, has successfully packaged these mysteries into digestible, thrilling episodes that ask viewers to question everything they've been taught about history. Similarly, authors like Erich von Däniken, with his groundbreaking 1968 book Chariots of the Gods, laid the foundation for this genre by suggesting that the gods of ancient myths were actually visiting astronauts whose advanced technology was mistaken for divine power. These ideas tap into a deep-seated human desire for a more exciting, mysterious past, one filled with cosmic visitors and forgotten global empires. The positive impact of this popularization cannot be ignored. Shows like Ancient Aliens have ignited a passion for archaeology and ancient history in millions of people who might never have picked up a textbook. They have asked provocative questions that, at times, have challenged a sometimes overly rigid academic establishment to reconsider certain assumptions. This widespread curiosity has, in turn, generated public support and funding for legitimate scientific research, including the LiDAR scans and geological dating techniques we discussed earlier. The popular versions of these theories have kept the conversation alive, ensuring that the mysteries of the megaliths remain in the public consciousness. However, this comes with a significant cost. The relentless drive for entertainment and ratings often leads to a dramatic oversimplification of complex issues. Nuanced arguments about the transmission of geometric knowledge or the gradual development of engineering skills are frequently cast aside in favor of more sensational claims. The presentation often relies on what is known as the argument from ignorance fallacy, which essentially states, "We don't know exactly how this was done, therefore it must have been aliens or giants." This approach bypasses the slow, meticulous work of real archaeology in favor of a quick and spectacular, but ultimately unprovable, answer. This is where the vital practice of critical thinking becomes our most important tool. Engaging with these ideas, whether in a documentary, a book, or an online video, requires us to put on our detective hats. We must learn to ask key questions of every claim we encounter. What is the actual evidence being presented? Is it a compelling geological fact, or is it a subjective interpretation of a myth or a symbol? Are alternative, mainstream explanations given a fair hearing, or are they dismissed out of hand? It's crucial to distinguish between an established academic researcher publishing their findings in a peer-reviewed journal and a television personality presenting a theory for entertainment. This doesn't mean we should dismiss all unconventional ideas outright. Many great scientific breakthroughs began as heresy, but it does mean we should weigh the quality of the evidence. For instance, the argument that the pyramids were built by aliens often hinges on the belief that humans 5,000 years ago were incapable of such work. This is not evidence for aliens, it is merely an expression of modern arrogance about the capabilities of our ancestors. A more productive approach is to marvel at the ingenuity they possessed, which we are still working to fully understand. The distinction, then, is not necessarily between right and wrong ideas, but between evidence-based hypotheses and speculative narratives. Serious researchers investigating potential cataclysms like the Younger Dryas impact hypothesis point to physical evidence like nanodiamonds in sediment layers and platinum spikes in ice cores. This is a scientific argument that can be tested, debated, and refined. In contrast, a theory that suggests a specific hieroglyph depicts a helicopter is often based on pareidolia, the human tendency to see familiar patterns in random shapes, and a selective interpretation that ignores the well-established context of Egyptian symbolism. The popular versions tend to focus on the what if without adequately addressing the how do we know. They create a compelling story, but a story is not the same as a historical reconstruction backed by empirical data. The danger arises when the entertaining story is mistaken for proven fact, leading to a public misunderstanding of both history and the scientific process itself. Ultimately, the relationship between pseudo-archaeology and serious research is a complex dance. The popular interpretations act as a kind of cultural amplifier, taking the whispers from the ancient stones and turning up the volume for a global audience. They get people asking questions, looking at the night sky, and wondering about the secrets of the past. This influx of interest is invaluable. However, it is the responsibility of educators, scientists, and content creators like us to then provide the tools for discernment. We must acknowledge the allure of the fantastic while gently guiding the conversation back to the evidence, encouraging a sense of wonder that is grounded in critical inquiry. The true mystery of the ancient world is not diminished by a rigorous approach, it is magnified. The realization that human beings, with their own hands and minds, could achieve such grandeur is in many ways more profound and inspiring than any story about extraterrestrial architects. The popular culture versions have opened the door for millions. Our task is to ensure that once they step through, they find a world of mystery that is even richer and more fascinating because it is ultimately human. So far, we have explored the silent, imposing language of geometry and astronomy, a message written in stone and aligned with the stars. But what if this ancient code was not meant to be seen, but also to be heard? We have been treating these sites as silent ruins, but emerging research suggests they were once vibrant with sound, designed as sophisticated instruments to manipulate acoustics in ways that could fundamentally alter human consciousness. This introduces a breathtaking new dimension to our mystery, the idea that the lost language was a multi-sensory experience, combining visual mathematics with a powerful sonic component. One of the most compelling examples of this acoustic architecture is found deep underground on the Mediterranean island of Malta. The Hal-Saflieni hypogeum is a labyrinthine, multi-level subterranean temple complex carved from solid limestone around 6,000 years ago, making it older than the Great Pyramid. Within its sacred chambers lies a room known as the Oracle Room. This small, oval chamber is an acoustic marvel. If you speak in a certain way, particularly at a specific pitch, your voice is amplified dramatically, echoing throughout the entire underground structure with an otherworldly resonance that seems to come from the walls themselves. The effect is not just simple echo, it's a targeted amplification that creates a disorienting and powerful sensation, as if the stone itself is speaking. Archaeologists and acoustic engineers who have studied the chamber believe it was deliberately designed to resonate at a frequency close to 110 Hz. This is not a random number. Scientific studies have shown that exposure to sound waves at this specific frequency can have a measurable effect on the human brain. Brain imaging scans indicate that activity in the language centers of the prefrontal cortex temporarily decreases, while activity in the right hemisphere, associated with creativity, intuition, and spatial perception, increases. In essence, the very architecture of the Oracle Room was engineered to produce a sound that could shift a person's cognitive state, potentially quieting the internal chatter of the mind and opening it to a more receptive, non-ordinary state of awareness. This phenomenon is not isolated to Malta. Let's return to the most famous ancient structure of all, the Great Pyramid of Giza. While its massive, empty chambers seem silent today, they possess their own extraordinary acoustic properties. The King's Chamber, built with immense granite slabs, is particularly resonant. Experiments have shown that the chamber acts like a giant sound box. The granite, a rock rich in quartz crystals, is piezoelectric, meaning it can generate an electrical charge under mechanical stress, such as the pressure of sound waves. When specific chants or drumming are performed inside the chamber, the sound doesn't just echo. It creates a standing wave, a sustained, immersive field of vibration that can be felt physically in the bones and chest. The frequency of this resonance appears to be tuned to the natural harmonic of the chamber itself. For someone inside, the experience would be overwhelming, a feeling of the very air vibrating, of being inside the sound. This was likely not an accidental byproduct of construction. The immense effort required to raise those granite blocks 70 feet into the air suggests that the acoustic effect was a deliberate feature. The chamber may have been designed not just as a tomb, but as a final initiation room where the deceased pharaoh's soul, or perhaps a living high priest, would be exposed to these vibrations to facilitate a transition between worlds, to resonate in harmony with the cosmos itself. This idea of using sound for spiritual transformation connects to a practice found in cultures across the globe, the use of rhythmic drumming and chanting to induce trance states. From the shamans of Siberia to the medicine men of the Americas, repetitive sound at a specific frequency, typically around 4 to 8 beats per second, has been used for millennia to guide participants into altered states of consciousness. This rhythm corresponds to the theta brainwave state, which is associated with deep meditation, vivid imagery, and a sense of transcendent connection. Now, imagine that effect being amplified not by a simple drum, but by the very walls of a massive stone chamber designed to enhance and sustain those frequencies. The architecture becomes a colossal amplifier of an ancient spiritual technology. The geometric proportions that create visual harmony might also be precisely the dimensions that create specific sonic harmonics. The circle, so sacred in its symbolism, is also the perfect shape for creating a uniform sound field, allowing vibrations to travel without obstruction. In this light, a site like Stonehenge, with its giant circular layout, might have been as much a concert hall as it was an observatory. The placement of the stones could have been designed to reflect and channel sound waves during ceremonies, creating an immersive auditory experience for hundreds of participants. The language of the giants, therefore, may have been one that was felt as much as it was heard or seen, a full-body experience designed to bypass the intellect and speak directly to the spirit. The most profound implication of this sonic theory extends beyond ceremony into the realm of healing. The modern field of sound therapy, or cymatics, explores how sound frequencies can influence matter. We know that specific frequencies can shatter a glass, but they can also create beautiful, complex geometric patterns in sand or water. If sound can shape matter, could it also be used to restore balance to the human body? Ancient traditions, particularly in Tibet and India, have long used singing bowls and mantras for healing, believing that illness is a form of dissonance and that the correct frequency can restore harmony. If the builders of the Hypogeum or the Great Pyramid understood these principles, then their structures were not just temples for the dead, but potentially hospitals for the living. A chamber resonating at a healing frequency could have been used for rituals of purification and restoration. The multi-sensory approach, the awe-inspiring scale, the harmonious geometry, and the mind-altering acoustics would have created a powerful therapeutic environment. This transforms our understanding of these sites from passive monuments into active, functional machines. They were sophisticated devices engineered to interface with human consciousness, using a unified language of form, number, and sound to guide people toward healing, revelation, and a direct experience of the sacred. The stones were not just speaking, they were singing, and their song was designed to change whoever heard it. This drive to uncover the secrets of the past, to decode the geometric language of the giants, brings us face to face with a profound and deeply modern ethical challenge. We are armed with powerful technologies like LiDAR and ground-penetrating radar, tools that feel like superpowers, allowing us to see through the earth and beneath jungles. The temptation is immense to press forward, to excavate, to uncover every last chamber and artifact. But this quest for knowledge is not happening in a vacuum. These ancient sites are not merely puzzles to be solved. They are sacred ground, fragile relics, and for many people around the world, they are living parts of a cultural and spiritual heritage that continues to this day. The question is no longer just can we investigate, but should we? And if so, how can we do it with wisdom and respect? Consider the act of excavation itself. While it has yielded incredible discoveries, it is by its very nature a destructive process. The moment a trowel breaks the soil of an undisturbed layer, that precise context is gone forever. An archaeologist in the 19th century might have carefully documented a pottery shard, but in the process, they would have unknowingly destroyed microscopic pollen grains that could have told us exactly what plants were growing there, or disturbed the soil chemistry that held clues to the ancient climate. Every dig is a trade-off. We gain one piece of information at the potential cost of another, more subtle piece that future technologies, yet uninvented, might have been able to read. There is a strong argument for a principle of minimal intervention. With non-invasive tools like radar and laser scanning, we can now map entire cities without ever breaking the ground. This approach allows us to preserve sites in a pristine state for future generations, who will undoubtedly have even more sophisticated ways of seeing into the past. It is an act of humility, acknowledging that we are not the final arbiters of this mystery, but simply one link in a long chain of inquiry. This responsibility becomes even more weighty when we consider the spiritual and cultural significance these places hold for indigenous and local communities. For the descendants of the Maya, the structures emerging from the Guatemalan jungle are not merely archaeological ruins. They are the homes of their ancestors, places imbued with profound spiritual power. For the Native American tribes of the American Southwest, ancestral sites are part of a living landscape, connected to their creation stories, their identity, and their ongoing religious practices. When outside researchers arrive with permits and funding, eager to dig and remove artifacts to distant museums, it can feel not like exploration, but like a continuation of colonial appropriation. It is the taking of not just objects, but of history itself. The very act of scientific analysis, such as carbon dating human remains, can be seen as a profound desecration, a violation of the belief that the dead should rest undisturbed. This creates a painful conflict between the Western scientific ideal of knowledge for all humanity and the indigenous right to cultural sovereignty and religious freedom. The path forward, therefore, cannot be one of simple conquest. It must be one of collaboration and partnership. This means that archaeological projects must increasingly be led or co-led by members of the local communities. It involves sitting down with elders and community leaders long before any research proposal is written, to listen, to learn, and to seek permission. This collaborative model transforms the process. Instead of outsiders coming in to extract data, it becomes a shared endeavor to understand a heritage that belongs, first and foremost, to the people whose ancestors built it. In some cases, this may mean that certain areas are deemed too sacred to be excavated, and their secrets are left to rest. This can be frustrating for the curious scientist, but it is a necessary recognition that some knowledge is not ours to possess. It is a balance between the right to know and the right to respect. This ethical framework also extends to the preservation of what has already been uncovered. The Great Pyramid has survived for 4,500 years, but the corrosive pollution of the modern world and the relentless wear of millions of tourists pose a greater threat to its survival than anything it faced in the previous millennia. The famous limestone casing stones were stripped away centuries ago. Today, the very stones that remain are being eroded by the elements. The question of how to protect these sites is as urgent as how to study them. Do we encase them in protective glass, altering their appearance forever? Do we limit visitor numbers, making them less accessible to the public? There are no easy answers, only difficult choices that weigh the value of access against the imperative of preservation. Ultimately, the ethical dilemma forces us to redefine what it means to solve the mystery of the ancient giants. The goal cannot simply be to crack a code and walk away. The true value may lie in the ongoing conversation itself, a dialogue between past and present, between science and spirit, between different cultures and worldviews. By approaching these sites with reverence rather than entitlement, with a spirit of partnership rather than possession, we do more than just protect fragile stones. We honor the legacy of the builders themselves, who clearly intended their work to endure, to inspire awe, and to speak across the ages. Our greatest discovery may not be a hidden chamber or a translated inscription, but the wisdom to listen to that message with humility, ensuring that our quest for knowledge does not become the very force that silences the voices we are trying so hard to hear. So, after this deep exploration, where do we stand? The evidence is compelling, the questions are profound, but the case is far from closed. In fact, we are standing at the threshold of what might be the most exciting chapter yet in this ancient mystery, armed with tools our predecessors could scarcely have imagined. The investigation is now accelerating, propelled by 21st century technology that is allowing us to ask new questions of these old stones and to search for answers in places we never thought to look before. One of the most promising frontiers lies not in the field, but in the digital realm, with the rise of artificial intelligence and sophisticated pattern recognition software. For generations, researchers have painstakingly compared measurements from different sites by hand, a slow and laborious process limited by human capacity. But what if we could feed the precise dimensions, alignments, and geographic coordinates of thousands of ancient monuments into a powerful AI? These systems can analyze data on a scale and at a speed that is humanly impossible, searching for subtle correlations and geometric relationships that have eluded us for centuries. An AI wouldn't just be looking for pi or the golden ratio. It could identify entirely new, complex patterns, perhaps a recurring pentagonal geometry or a specific astronomical alignment shared between a site in Egypt and one in Cambodia that no one ever thought to connect. It could analyze the spatial distribution of megalithic sites across Europe to see if they form a larger, continent-wide geometric grid, a concept proposed by researchers like Alfred Watkins with his ley line theory, but now testable with rigorous data. This isn't about replacing human intuition. It's about augmenting it with a powerful new lens, allowing us to see the big picture in a way we never could before. The stones have been holding their patterns for millennia. We are only now developing the cognitive ability to recognize them all. While AI scans the data we have, another frontier is expanding into a domain that has hidden its secrets for even longer, the world beneath the waves. Conventional archaeology has been largely landlocked, but we must remember that sea levels have risen dramatically since the end of the last ice age, by nearly 400 feet in some areas. Vast stretches of coastal land that were once home to human settlements are now submerged. The search for these sunken landscapes is no longer the stuff of fantasy. Advanced sonar mapping and underwater robotics are allowing marine archaeologists to systematically explore continental shelves around the world. The discoveries are already beginning. Off the coast of India, in the Gulf of Combat, sonar images have revealed what appear to be geometric structures and drainage systems at depths that suggest an incredible antiquity. Similar investigations are underway near the Japanese island of Yonaguni, where massive terraced formations challenge conventional timelines. Finding a well-preserved settlement on these drowned lands would be a paradigm-shifting event. It could provide the missing link, a coastal civilization that acted as a hub for the diffusion of knowledge, its ports now silent under the ocean. The artifacts recovered from such a site, tools, inscriptions, or even the layout of its buildings, could provide the crucial context that connects the geometric language of the Eastern and Western hemispheres, proving once and for all whether these ancient wonders are the product of a connected world. This brings us to the ultimate dream of every researcher in this field, the search for a Rosetta Stone. The original Rosetta Stone was so revolutionary because it contained the same text in 3 different scripts, including known ancient Greek, which allowed scholars to finally decipher Egyptian hieroglyphs. For our geometric language, we need an equivalent, a site or an artifact that clearly and unambiguously translates the abstract proportions into a known language or a clear, practical function. Imagine discovering a chamber, perhaps sealed within a yet unexplored passage in the Great Pyramid, that contains not a treasure of gold, but a treasure of knowledge. Walls covered in detailed diagrams showing the geometric principles used in its construction, accompanied by explanatory text in a decipherable script. Or consider the potential of finding a preserved toolkit from the master builders, with measuring rods not just for the Egyptian cubit, but for other units like the megalithic yard, complete with instructions on their use and their relationship to astronomical measurements. Another possibility lies in the oral traditions that might still be alive today. While many were lost, some indigenous cultures possess deep knowledge passed down through generations about the sacred sites on their lands. A breakthrough might not come from a shovel, but from a respectful collaboration where an elder shares a song or a story that finally explains the meaning behind a specific alignment or proportion, providing the key that unlocks the entire system. The most profound unanswered question, however, remains the why behind the immense effort. We can understand the how of ramps and levers, and we can map the what of celestial alignments, but the fundamental motivation is still a mystery. Were these structures primarily spiritual machines, designed to harmonize human consciousness with the cosmos? Were they vast repositories of practical knowledge, encoding everything from agricultural calendars to navigational charts for a civilization afraid of losing everything in a cataclysm? Or were they something else entirely, a project on a planetary scale whose true purpose we have not even begun to fathom? The next discovery, whether it's from a satellite, a deep-sea drone, or a long-forgotten manuscript, could provide that crucial piece of context. It could reveal that the geometry was part of a global energy grid, a notion explored in some esoteric circles, or that it was a message intended not for us, but for some far future intelligence. The mystery is so deep because the answer likely doesn't fit neatly into any single category we have today: religious, scientific, or practical. It may force us to create a new category altogether, one that acknowledges that our ancestors operated with a worldview that was entirely holistic, where science, spirit, and art were inseparable. The stones have guarded their secret for thousands of years, but with every technological leap and every new generation of curious minds, we move closer to the day when we might finally understand the message they were built to convey.